Horgan. Oh, that's fine.
Good morning, everyone. Welcome to ShortStack Con, the first of our runnings. So apologies if things are a little scuffed. If you don't know what ShortStack is, it's a conference of lightning talks, of 10-minute talks throughout today for about, I think, the next 6 hours, 5-6 hours. And we're going to be talking about all range of topics, mostly tech adjacent, so something related to tech in some way or another, but kind of a very free reign with a lot of diverse topics, a lot of people from all over the world. We're super happy to be here. I'm super happy to be hosting it. My name is Evan. I'll be your host for today. I'll be introducing the talks. I'll be doing a little chat with everyone after their talk to do a bit of Q&A from either the chat or in the Discord server, and I'm just really excited. I hope you all are too. The format today will be, so we have 14 talks, and each talk will be 10 minutes, and there'll be a 5-minute Q&A after each talk, and then there'll be a 5-minute break. So that'll be the cadence for today. 10 minutes, 5 minutes, 5 minutes. And then we'll have a couple breaks, but the breaks are the length of those 20-minute slots. So we keep the same cadence. It'll be fun. I think that's all the explainer that anyone needs. I'm going to shut up and we're going to start in about maybe 7 minutes with Rose Farrel, who'll be doing a talk on how recruiters get the information that they do and all the techniques that go into it. Things like social engineering, API manipulation, a bit of OPSEC. It was very exciting, kind of like a little murder mystery. I'm looking forward to it, and in about 7 minutes, I'll be happy to welcome Rose onto the stage. So, talk to you very soon.
I'm good. I'm just getting my links in order. I'm just going to share my screen and like practically show how people hack all their shit. So I have a small presentation, but it's really just for people to look at when talking. And that's my final slide. And then the connection seems a bit dull. Hold up. Cool. And then I'm gonna demonstrate. Avoid coming back to my own screen because of hilarious tesseracting. I know. So everyone's got it. You've gotten an email from a recruiter and you're like, I'm fairly sure I did not give you that information. And also, why are you talking to me? There's a bunch of different ways that recruiters do this. So I'll take you through some of the most common ones in a live, dramatic way. So the first one is you literally gave them your email address. You applied to a job ages and ages ago and you don't remember, but you did. If you apply to a job on LinkedIn through a company, it keeps your adverts there, or it keeps your applications there for quite a long time. This is my profile. I apply to my own jobs occasionally just to see in January. I might have forgotten about that, but my CV is still here. And you can get my email address and stuff there. So that's the simplest explanation. The other way, that's the simplest explanation, is that you're connected to them on LinkedIn. So you can see here, I've got Kian's details because I'm connected to him on LinkedIn. He's my boss, so he doesn't mind me sharing all his information. So those are the easiest ways, but I'm going to go into some of the more sneaky ways now. The number one tool recruiters use is probably one of these extensions. Like, there's a lot of them, but this one is called Contact Out. And you look at somebody's profile and you click the link and it brings up email addresses. So I can see I've got his Hotmail email address. That's his personal email. That's good, because you don't want to email somebody, do you want a job, at their work email address, because it's a bit weird. I've got his phone number, and I have limited credit, so I'm not going to click that. And you can see on my own profile here, it pulls my work email address because it's on my profile. And I have this kind of binary joke on my profile, so it's after pulling all of those numbers too. I don't actually know how Contact Out works. They obviously protect, excuse me, they obviously protect their information. So yeah, they're not going to tell us how they get that information, but a lot of it is just your public information with LinkedIn. So going into much more devious ways. Making sure I've got the right link there. Ooh. So if you've got somebody's GitHub account, so I've got Raphael here, that you can use a little API hack. So this is just a link. And if you put in their username into the link, and ta-da, I've got a bunch of information here. I've got like repositories he has, I've got his login, or sorry, his username, and I have email address. So I can email him now and ask him if he wants all of my jobs. If that doesn't work, if somebody has their privacy settings set so this doesn't work, you don't have to fear, you can continue. This is really like high level sneaky stuff. You can go into repositories. If you pick a repository that they've used, and then what you're looking for is the commit link. You know, I've got the right one and it's got all of this stuff at the back. And then you put in .patch, and ta-da, I've got the command line commit information. So you can see it's a bit of his README and the details in the code, and his email address is here at the top. And I can email him and say, do you want all of my jobs? After GitHub, if you still don't have somebody's information after that, well, you should kind of give up because they clearly don't want to talk to you. But if you're really like obsessed and you think this person is the greatest and they will love my job when they hear about it, there's some other things you can do. If they have a username attached to their profile, literally just Google the username. I mean, tech people are really loyal, so they tend to keep their username. And here we've got loads of stuff. We've got DeviantArt, we've got his GitHub, which he isn't on his profile, so that's exciting. I can use the API thing on his GitHub. And I've got other stuff. And if you don't want to like search through all of that, if you just take some of the more common email providers and do a wee search, and ta-da, I've got his email address, which is from GitHub, but you can see it's also here from a completely different website. So yeah, that's an option. And then I can again email him. And there's Oisín software that you can use to just check absolutely everything for that email address. Like I could go poking about on Reddit to see if he posts there or something and has added his email address. So, I mean, that's all terrifying, but what can you actually do to stop this? So remember, your information is legally protected if you live in the EU because of GDPR. I can find somebody's email address, but if they didn't put that email address there for the purposes of me contacting them, then I shouldn't be doing it. It's kind of you could argue it either ways. You could say, well, I have his information and now I'm going to ask him if he wants jobs. But if they don't, then I should remove his information. But check your local data laws. Like everywhere has some sort of data protection and data privacy laws, so check that. When you get the email, ask how they got it. And yeah, they have to tell you. They should tell you. Shut down your information. If you go into GitHub, you can, in settings, to click keep my email address private. It changes the commit address to this obfuscated like alphanumeric string that is something like @github something. So that's no good to anyone. For anything job related or anything professional related, like your personal professional stuff, use a special email address so that if somebody's legitimately contacting you because you applied to a job or you gave them your contact details for that, then you'll know it's legit. But if it's like your personal email address and you're like, I'm fairly sure that the only place that exists is on like forums and GitHub, then you can be like, well, I did not give you that information. How did you get it? Stop contacting me. So yeah, those are the main ways. If that actually does sound really fun, because I have to say I'm really into Oisín, and I found it really interesting. There's this sourcing.games. It's like a CTF for recruiters. And there's a bunch of different sourcing games that you can use or you can have a look at, and it teaches you quite a lot and it's pretty fun. And so yeah, those are the main ones. It's a whistle-stop tour. I mean, realistically, recruiters are far too lazy to do any of that. It's much easier to just use the email address that's easily available to you, and if you can't find it, just move on to someone else. But you know, depending on how hard a role is, you might be really going down into corners to find someone. So that's me. So if you have questions or anything, I guess Evan will field.
Yeah. So one, that's wonderful and terrifying. In equal measure. I didn't realize there was quite that much exposed. Like I kind of knew in the back of my head that every commit to GitHub was releasing my email. This is a little scary. I'm gonna have to change my settings.
Yes.
So I was wondering how much time have you sunk into sourcing games? I imagine you're on the top leaderboards.
I'm not actually. I haven't played it in ages. I got the first 10 games or first 11 games done, but I noticed now he's up into the 30s, so I'll have to go back to it. Yeah.
Yeah. Actually, something I was wondering. So you mentioned that that recruiters are generally quite lazy and they'll just use whatever email they can get. But is this kind of like cold emailing beneficial?
Um,
Or is that debatable?
it's debatable. I mean, if you email enough people, they'll eventually reply, and or some of them will reply. A lot of the time when I'm sourcing, I am looking for somebody for the job I have in hand, but I'm also looking to make connections. So I could email you and be like, "Oh, I have this job," and you're like, "I don't want that. I want something else." And I'll think, "Cool, I've made a connection. They've responded to me.
Yeah.
I can." Maybe they'll think I'm a nice recruiter and they'll come to me the next time they're looking for a job.
Yeah. Okay. Yeah. That makes a lot of sense. And well, I guess this is like kind of a more this information is more generally useful than just in shielding against recruiters. I imagine
Oh yeah,
especially with the prevalence of OSINT these days, that you should be kind of trying to lock down as much as possible from other people as
for
well.
for sure. There's an endless pile of tools. There's a tool called Sherlock that if you put
Okay.
in somebody's username, it searches everything
Oh wow.
to
Okay.
look for their email address. I feel, with all due respect to recruiters, it's a bit beyond them because you have to actually go through the command line to install it and use it. And again, it's a lot of effort.
Okay. So
You don't want to put 15 minutes into looking for each email address.
Yeah, I suppose. I suppose it's more beneficial to those who are maybe going through verification, for references or something. Yeah. Actually, do you have any other tips outside of what you mentioned, outside of specifically for combating recruiters, just general kind of
Literally
information
Google
security?
yourself.
Okay.
Like, oh, I'm dead. That's good to know. But yeah, Google your name and Google a couple of associated things
Mm.
to see just what comes up.
Okay.
Again, my stuff is pretty locked down because I've run all of this on myself, and I was finding stuff like my old email address buried in mailing lists from 10 years ago.
Yeah. I suppose I'm going to have to do the 30 Rock and go Google myself in my office.
Yeah.
Well, thank you so much. We're out of time for questions at the moment. Up next, we've got Leander, who will be talking about putting on your own mask first. So it will be about helping people through trauma and crises. Looking very much forward to that. Thanks again,
Cool.
Rose, and I'll talk to you soon.
Bye.
Hey, Evan. Yep. Yeah, likewise. Oh my gosh, Rose's talk was amazing. Hello and welcome. This talk contains information about sexual assault and violence, which may be triggering to survivors. So take care of yourself. I'd like to pretend that you'll never need to worry, need to know how to help a friend, because we've all lived in a world without war or violence or abuse, without trauma. But just in case my pretend world doesn't exist and you find yourself needing to help someone or to help yourself, listen up. Recovering from trauma feels like a roller coaster with rumination, flashbacks, depression, anxiety, and hypervigilance. I'd like to offer you an invitation to get off the roller coaster and come fly on Leander Air, where we'll learn how to help our friends who have experienced trauma. It might sound a little bit something like this. Hello, and thank you for flying with Leander Air. A few announcements as we begin our talk. There's no safety card in the seat in front of you unless you're watching this from a flight, in which case, where are you headed today? So in this case, the seatbelt is actually food. One of the most important, one of the most important ways to survive day to day is to eat. And when you're hungry, the world seems like a very dark place. And with something in your belly, it's not so dark. Immediately following trauma, one of the most basic things to forget is food, is eating. So eat, that's your seatbelt. Even if it's just a quick protein shake, 250 grams of almond milk, 1 banana, 2 tablespoons of protein powder, 1 tablespoon of flaxseed, if you like, 1 heaping spoon of peanut butter, blend it up, drink it down, and set an alarm on your phone to eat at least 3 times a day, even if you're not hungry, because you might not be. I understand it, but your body needs food to survive, and you need calories to heal. If you or someone you love is in danger of hurting themselves or others, call 112 or 911 or whatever the emergency line is in your country and ask for help. Your closest exit is not suicide. It's never the answer. But asking for help, that is your closest exit. While yes, a life vest is probably not located under the seat or the seat in front of you, there are several coping strategies that are already within your reach. Go for a walk, get outside in any weather. There's no shitty weather, just shitty clothes. Put on the rain boots, raincoat, rain pants, bring the umbrella. Don't forget all the layers. Yep, the extra scarf too, those gloves. It doesn't matter how you look, as long as you're warm, get outside. And drink a cup of tea or coffee, it's fine. Put the kettle on, not too much water so it can boil faster. Is it before 2 o'clock in the afternoon? Black tea with lots of milk, if you like. After 2 o'clock, green tea with lemon, please. The goal is to do a little familiar ritual that you did when you were healthy, like making a cup of tea or a cup of coffee, and to raise your temperature inside and out. While you're sipping your hot drink, wrap up in a favorite blanket, put on those soft jammies, get the temperature up. And finally, for me, bake. I have this super simple chocolate chip cookies recipe with 2 cups sifted flour, 1 cup melted butter, 1 cup of sugar, teaspoon of baking powder, teaspoon of vanilla, pinch of salt, an egg, as much chocolate as I'm feeling like baking those. Using your hands to mix things and get messy. And the reason why this is so important is, 1, you are tempting yourself with chocolate or something that is normally tempting to you as a curative. 2, you're actually using your hands and physically playing with something. And 3, you're getting calories that are warm, which raises your temperature. There are so many coping strategies out there that I could do an entire talk just about coping. These are 3 quick ones, but please Google if you need help. Coping strategies. Please let us know if you need any help. So after a trauma, please seek help. Ideally, professional help, but I totally get if that seems overwhelming at first. If you don't feel like you can reach out to anyone, I'm Leander on Twitter and most other social media, and I'm here for you. You don't need to suffer alone, and what you're feeling is completely normal and understandable, but you need help. Don't stay alone. This is maybe obvious to people who are parents, but not as obvious to people who are friends. You can't take care of others unless you take care of yourself. So for example, imagine yourself in the plane and the oxygen mask comes down. If you are trying to get the mask on someone else who is maybe also panicked, you're losing oxygen. You're not able to breathe. But if you put your own mask on first, then help others, you are more likely to help them and not die. Ladies and gentlemen, welcome to ShortStack Conference Airport. Local time is 12:26. Temperature is 22 degrees Celsius and 70 degrees Fahrenheit here in the Netherlands. Please check around your seat for any personal belongings you may have brought on board with you. And please use caution when opening the overhead bins, as heavy articles may have shifted around during the flight. On behalf of Leander Ayres and the entire crew, I'd like to thank you for joining us on this trip, and we look forward to seeing you on board again in the near future. Enjoy the rest of your conference. Oh, here's the thing. This is a silly little talk, and it's got some valid points to help you recover, to help your friends recover. But the reality is that everyone's different. Every trauma is different. And I can really only give advice as a survivor. I'm not a doctor. I am not the professional help you're looking for. I am not your medicine. But I have survived. I have been through trauma a few times. And unfortunately, I understand what you're going through. And I've taken care of myself for many, many, many years. I do have kids. I have taken care of them. But sometimes when I'm feeling wobbly, I go back to my coping strategies that I know work for me. And I do them again and again. And it's a process. You will never completely heal. You will always have triggers. You will always have moments that come back to haunt you, and that sucks. But you will always have your coping strategies, and you will always have your friends here at Leander Air. Thank you. I can. Apparently I can't, because I closed, like I went way too fast. Oh yeah. Hi. I love it. It's all good. It's all good. Yes. Yes. Yeah, it's hard, right? So take a minute. This, I completely didn't even put this in as a coping strategy, but just taking a pause, a breath.
Yeah.
It's totally fine.
Okay.
So one of the reasons why I applied to this conference is I am a professional speaker, but I'm not good at speaking about this.
Yeah.
And I want to be better.
Yeah. I get that. It's a very tough subject to be very honest about. I know for myself that I've been through quite a bit of therapy. I have my own issues, and it gets easier to be open about it, and you realize kind of how much it helps people. But it doesn't make it any easier to be open about it.
Exactly.
Yeah. So one question that did come up is like you mentioned asking for help quite a bit, and you mentioned kind of like some avenues for where you could ask for help, but do you have any answer for how do you ask for help?
Right. So I've sadly experienced a lot of different ways of asking for help. So I live in the Netherlands, but I've also lived in the United States. And I've found that in the United States, that if you tell a doctor or a professional or even a friend, depending on the friend, you can stay pretty calm and be like, I've had this trauma. I need to deal with it. Please help.
Mm-hmm.
In the Netherlands, it's been my experience that you have to cry and you have to express the emotion and the torture that you're feeling, or you won't be taken seriously. And that's kind of sad that you have to break down and cry in order to convey the seriousness of the situation. Me personally, I don't cry in front of strangers. So, but then when I do cry in front of strangers, I am hysterical and cannot communicate. So I actually had to ask a friend of mine who spoke Dutch. I speak Dutch very well now, but back then I didn't. And I said, this is what's going on. This is the seriousness of the situation. I need your help to get help here in the Netherlands. And they did. They were able to, basically express the seriousness of the situation and get that urgency across without me losing it. But I understand it's very hard. Sometimes I write to ask for help. Sometimes I call a friend to ask for help. Sometimes I have been in the situation where I needed to convey that it was urgent, that it was an emergency. And I think the key there is don't give up. Don't stop asking. Don't decide. If you don't get a response that you need to heal, keep asking. Someone else, maybe.
Okay. Yeah, I think that's really good advice. Thank you so much for the talk today. It was very good, very moving. Up next, we will be seeing Sayan Mondal, who will be talking about chaos engineering and resilience through use cases proliferated through your organization and through your infrastructure. Thank you again, Rain, and I'll talk to you again soon. Bye.
See you. Bye.
Hey guys, welcome to this talk on Break It Till You Make It, Break It Till You Make It, which is on chaos engineering. And this entire talk will be based on chaos engineering and cloud native, and how you can mix the two together. And I'll also show you different tools. And one of the tools, which is Litmus, which I work on. So who am I? My name is Sayan. I am a software engineer at Chaos Native and also a co-contributor as well as a team member of Litmus, which is the cloud native chaos engineering toolkit. Now, the few agenda topics that I've mentioned today is what is chaos engineering, why would you need it, what are the problems, what is cloud native chaos engineering, what are the different tools in the market, and also we'll see what is Litmus. So what generally is chaos engineering? It's basically the practice of breaking things in production, but it's not just production. You can do it also in the ops. Like it's something that the ops team should do. You can also do it pre-production or also on your staging cluster, also on the dev side. Now we generally never like downtimes. Downtimes are really expensive, so we want to mitigate that. And chaos engineering is just a practice which helps you target your application and break it manually so that you do not face that in the real event. So it makes your application more resilient. Now, we want to do the testing in mostly the right side of the DevOps loop. What we generally do is we mostly do it in the left side, where we have E2E tests, unit tests, and smoke tests, and all these different kind of tests. But we want to shift the idea to focus more on the right side of the DevOps loop. Now, typically it's done via game days. We rarely integrate this sort of a system in CI/CD, and it's only specific to SREs as of now. The way chaos engineering is happening, but we want to enable more people out there to try it out. Mostly planning and execution is done manually, and there's no automation as of yet. And observability is not really something that comes pre-packaged when we talk about chaos engineering. So what is cloud native and cloud native chaos engineering? So cloud native is basically the practice of taking cloud computing and putting it a notch up by making things much more scalable, extensible, elastic, as well as flexible, when we're leveraging most of the concepts of the cloud computing and we're putting it up a level. So when we do cloud native chaos engineering, we focus on 5 principles, which is open source, and it should obviously have community collaboration if it's open source. The APIs and the lifecycle management should also be open. What I mean by that is, if you have any API and if you have any management set, which it should be flexible and open enough for any other solution to integrate smoothly into. The observability should be open, and you should not be scoped or limited to any certain monitoring platform. It should be open for any solutions to integrate into. And we also want to we highly recommend having GitOps as a part of the 5 principal stack of cloud native, because with GitOps you get a much more version control and like a task-based versioning system, which helps your not just the dev team but also the ops team. Now, the different tools that are out there in the market currently are Chaos Plate, Chaos Mesh, Chaos Toolkit, and much more. But these are the same, doing a similar approach like we are doing in Litmus, so which is enabling chaos engineering on top of Kubernetes. But they are great tools, but all of not one tool can be perfect. So all of them have their flaws, and a few flaws that are currently there in the market is some of them may be very good, but their market is only scoped to a certain area, and they have a limited set of documentation, a limited set of very good documentation, but limited set of languages. So the availability is not that high. Some of them have very good dashboards, but they are not really very secure. And some of them do not support data scheduling or are not really portable. So what we tried to do with Litmus is we tried to incorporate all these 5 principles of cloud native chaos engineering, and we as you can see, all of them are ticked. So we tried to mitigate all the problems, all the issues that were there in the other tools and that were there generally in the market, and we were successful in doing so. So what is Litmus? It's basically a cross-cloud chaos engineering toolkit. It started out as a toolkit. Now it's more of like a framework because you can integrate it with anything, and it helps SREs to add this particular solution in their own enterprise requirements, and then induce chaos with the help of this toolkit. And then you can create workflows with multiple number of chaos experiments, and this set of chaos experiments which turn up to be workflows can be induced on your application to check the application's resiliency. So what I mean by that is, let's say you have experiment A, experiment B, and C, which might be anything like killing a pod or killing a container, and you can chain all of them in certain order, whichever you want. And if you induce chaos on that, and there's two concepts of steady state and hypothesis. So if your steady state is, let's say, everything is working fine, and your hypothesis is, I would want to kill this particular container or particular pod, and I want them to be back up again. That would mean that if they're successfully back up, then that means your system is pretty resilient, and your chaos injection, the idea was perfect. So upon the hypothesis, you should reach back to your steady state. So that would mean that your chaos experiment or the entire idea was pretty good, and your application is resilient. So that is what you have to keep in mind when you do chaos engineering, and Litmus enables you to do all the things. So moving forward, we have a list of experiments, which is, we are proud to say that, which is pretty high than all the other toolkits or tools available right now. So we have a lot of experiments which are both Kubernetes specific as well as non-Kubernetes, and these are the main chunks of pod chaos, node level chaos, network level, or stress, or even cloud chaos, or even application specific chaos. Like you can induce chaos in, let's say, Cassandra, Kafka, OpenEBS, or any other application. So this is the public chaos hub that I just told you about. This is called Litmus Hub. Chaos Hub. So a public Chaos Hub would already be integrated when you install this particular tool, Litmus. And there's also an option to install a private Chaos Hub, which is, let's say, your application, your enterprise has a certain requirement which is private. Then you can also create your own charts, and then you can integrate them into Litmus. Now, Litmus can run both on cloud as well as on-prem setup, and it can also run on VMs as well as bare metals. And it is wrapped entirely in Argo series, so whatever you do would have a beautiful visualization, as well as you can export metrics out of it too. So if you are using your own analytics solution, you can clearly export the certain chaos resources that were created as a part of the chaos injection, and you can pull those metrics out to your own analytics solution, and then you can monitor the same. You can use your own observability. So typically, it is not just scoped to the ops team, like I mentioned before. We want to enable more people, more personas out there, more developers, more DevOps people to try it out. So it's not just scoped to SREs, which is why we have chaos in CI pipelines too, which is when let's say a developer is setting a PR or doing something in the CI pipeline, you can induce chaos there as well. And we have 4 different templates, which is GitLab, GitHub Actions, Spinnaker, as well as Captain. So you can use this particular sort of template, which we call as a chaos stage, which is let's say you have application A and chaos pipeline in the flow. There's a flow A and there's a flow B. So you can integrate this chaos stage in the middle, and that would actually enable you to add certain experiments, certain chaos experiments that you want to do, maybe a pod delete, maybe a node level experiment, and you can add these experiments in sort of sequence in the GitHub action or something, and that would be actually executed in your CI pipeline. So it makes things much more easier for developers too. And if you have a staging cluster or pre-production cluster, then of course you can install Litmus in there as well, and then you can try the entire flow out naturally without having to do it in CI pipelines too. And also for Kubernetes versus non-Kubernetes, you can induce chaos in non-Kubernetes cloud providers as well. So you need a network access control API, which then induces chaos on, let's say, AKS or EKS or GK, or even VMs for that matter. So you can see VMware. So there's an experiment of VM power off as well, which powers off your VM. So that is done natively on VMware. So you get all the certain capabilities with Litmus. And yeah, that's all about cloud native chaos engineering, and about the product Litmus, which you can use to do cloud native chaos engineering. Thank you.
Awesome. Thanks for the talk. Yeah, so that was really good. You kind of described the general idea of chaos engineering and of Litmus. Can you keep your presentation open if that's okay?
Sure.
Yeah, so I was wondering, where would someone start with chaos engineering? What are the first kind of things they should do to start down the journey of chaos engineering?
Well, in the initial stages of chaos engineering, what they can do is they can start off with like creating certain pods in your microservice architecture, and then just particularly trying to delete pods. That is the standard experiment. And there's also something like very default, de facto experiments, which are sock shop as well as potato head. So these are all part of CNCF. So if you want to just start out, then you can try out Sockshop, or you can also try out Potato Head. So these are very Sockshop is like an user-facing e-commerce sock selling this application, which is just done for demos, and so is Potato Head. So you can kill individual pods, individual containers as you wish. That will give you a general great idea about chaos engineering.
Okay. And is there any scope for doing this without like a virtualization setup? Say if you have set up with bare metal, is there any advice you would give for doing chaos engineering with that?
Yeah, so all you need, if you have, let's say, a Minikube or K3s or even kind cluster set up in your system, then that is perfectly fine. You can run it at the bare minimum of 2 CPUs and very low memory requirements. So you can just install Litmus on top of that, and you can create your own chaos in your dev cluster. So that would be perfectly fine. So you don't need a full-blown setup to do that. Mm-hmm.
Yeah. Okay, that's very interesting. I suppose one of the very important things about chaos engineering is the outcomes. How do you measure the outcomes? Like, what are good measurements of outcomes?
Okay, so with Litmus, Prometheus is already integrated. So when you install Litmus, you get Prometheus along with it. And when you enable this particular monitoring setup, you also have Grafana, which allows you to view this all different metrics that we do when we use chaos. So there's also one of the CRs that we use called chaos result, which is integrated with probes as well. So probes are like pluggable checks in your system when you want to do some chaos engineering. So let's say HTTP induce HTTP chaos or CMD based chaos or something you want to run in the bash while you do so. So whatever kind of chaos you would do, this chaos result CR would always pick it up, and that would generally give you a verdict of how the experiment passed or not, what actually happened. And also these metrics that are generated as a part of chaos, you can also view it via Grafana, and you can see the spikes going up and down. And also if you click on that, it'll also show you this particular CR, the chaos result, in a verbose manner. So with the help of that, you can of course understand, and also you get logs as well on the UI, so that helps.
Okay, yeah, that makes sense. I suppose a sort of pseudo question from the chat is like, do you have a way of simulating a cat walking across your keyboard with a root open shell?
No, not as of now. We'll work on that.
Yeah, actually another question just came in. At what scale do you need to get meaningful measurements without too much risk of regularly taking down prod? Tens, hundreds?
Yeah, so generally what we do is we have a very basic 2-node cluster which is running out there, which is the standard DS2 VM, which is the very basic VM, and we keep it running, and we just do a recurring schedule. So let's say we just run a cron workflow, and that keeps running on our system, on our pre-production cluster, and then we just try to track, we just try to induce chaos on our own pods that we use. So that way we see what in case of new release changes or GA builds, if something broke or not in our production setup. So yeah. At a basic level of PS2 VM, you get a pretty good amount of chaos injected. But let's say you want to do crazy things, you want to add multiple parallel experiments or do a lot of sequential experiments, you would definitely need more memory.
Okay. So is there any minimum you would recommend in terms of instances or resources?
Minimum is 1 node, 2 CPU cluster. That would be fine. With a 4 GB RAM, that would be pretty good.
Okay.
Yeah.
Well, thank you so much for today. Up next, we have Kilian Valkhof, who will be talking about the prefers reduced data media query, which is due to come out very soon. It's making the world a little bit more accessible, and we're going to hear more about it. So thank you again, Sayan, and I'll talk to you again soon.
Thank you for having me.
Hey everyone! Prefers reduced data is a new media feature that people can use to indicate that they want to use less data when visiting your site. Very quickly, media features or media queries are what make responsive design possible by letting developers adapt their sites to their users' device capabilities, like screen size. Recently, browsers have started adding prefers media features like dark mode that let developers respond to a user's preferences rather than just their device capabilities. While prefers reduced data is not supported in browsers yet, support will land soon. It's available for testing right now behind a flag in Chromium browsers and available by default in the Polypane browser for developers. So why this media query? The average size of a web page is about 2 megabytes, and it's been slowly rising for the past couple of years. That means that if you have a 1 gigabyte monthly data cap, you can visit 500 web pages, or just 16 pages per day. Just for fun, check how much tabs you currently have open. With just those, are you over your daily budget of 16? Of course, the types of pages you visit will greatly influence this number. Wikipedia will last you a lot longer than scrolling through Facebook or Twitter, or indeed watching a Twitch stream. Also, equally important, the speed of a connection can influence your experience. I'm located in the Netherlands, which sits at number 12 on the worldwide speed index with an average of 100 Mbps, meaning I can comfortably stream live video. But if you're in, for example, India, your average internet speed is much lower at just 15 Mbps. You can bet that you would rather want smaller, faster sites. India, by the way, has the second highest number of internet users in the world, only behind China. Reducing your web page's size helps with both load time for people with slower internet connections and them having access to your pages in the first place. Lastly, there's also the people that just prefer sites to be as fast as they can. It's worth noting that there is an HTTP header called Save Data On that is already in widespread use that can tell you at an HTTP level when people prefer using less data. It's a little out of scope for this talk, and it's not as easy to use as the media query, but it's good to know that it's there. So how do we get started with prefers reduced data? Well, first off, the media query has two values, no preference and reduce. Ideally, you would implement the reduced data version of your site as the default version, and only when the user has no preference, give them the full VoD experience. Unfortunately, because there is no browser support at the moment, this means everyone gets the reduced data experience, and that's probably not something you can get buy-in for right now. So practically, we have to switch it around and implement our data preserving features in a prefers reduced data reduce media query. The nice thing is that while this won't do anything now, it will automatically start improving your site once support for the media query lands in browsers. There are three file types that cause the majority of web page weight: images, fonts, and videos. I'll discuss strategies for each of these. Starting with fonts. The nice thing about fonts in CSS is that they're only downloaded when they actually get used on the page, as opposed to when you define them in CSS using @fontface. So if you fall back on the system font, using, for example, this font stack, then you prevent a potentially large font file from downloading. Using the system font is usually a fine alternative and has the bonus of always looking readable to your visitor because it's the same font they see everywhere on their screen. You can always choose to send a smaller subsetted font when the chosen font is important for the branding of your site. Make sure to use it just for the branding and ship only the characters you use to keep everything small. Background images tend to be large, so if you can replace them with either a solid color or a gradient, then that should be your first choice. You can think of the background images as a way to enhance your page when the user is fine with using a bit more data. If, however, the background image is essential, you want to consider doing three things. You want to use a modern format like WebP or potentially AVF for the images. The new versions of browsers that implement prefers reduced data will have support for these modern image formats. For the reduced data image, you can use a smaller image and zoom that in. It won't look perfect, but it could be good enough. On the other hand, you can also use a large image, but with a much lower quality setting. The quality can be set much lower for larger images, and formats like WebP and AVF have specific algorithms that make sure certain high detail areas of the image remain clear. To serve smaller content images, the images on the page, we can turn to the picture element and provide a source with the prefers reduced data media query, like so. While there is no support, this media query attribute will evaluate to false, and then start matching one support lens and switch out the image for your lower quality one. Here again, you have the choice of serving either a smaller image or the same size, but with less quality. You will have to experiment to find what works, and for example, use squoosh.app to figure out the sweet spot for your image. While it's generally a nice experience when a video has buffered by the time you press play, that involves downloading at least part of the video in advance. When a user prefers to use less data, it means they will also be okay with having to wait just a little while for a video to start when they press play. To implement this, we need to set the autoplay and preload attributes on a video element when there is either no support for prefers reduced data, or there is support for prefers reduced data, but there's no preference. For that, we need this bit of hacky CSS inside JavaScript. The window.matchMedia API lets you test if a given media query applies to the current browser window. The media query we test for is essentially if prefers reduced data does not match, or if prefers reduced data does match. Then evaluate to true. Because of that or, which is the comma, it will always be understood and evaluate to true if we support prefers reduced data. However, if the browser does not understand or know about the prefers reduced data media feature, it will ignore the entire media query, and that results in it evaluating to false. That way, we have a way to test if prefers reduced data is supported by the browser at all. Then, we also check for the no preference directly, and we use the same window.matchMedia API for that. This no preference variable will be false either when reduce is true, so a user wants to use less data, or when there is no support. So what we need to do is combine it with the supported value to figure out if we can autoplay, like so. Either there is no support and we autoplay, or there is support and there's no preference to use less data. Lastly, by only setting the attribute in JavaScript, we make sure that we default to not autoplaying and not preloading when the JavaScript doesn't load. As an additional note, before you autoplay video, make sure that the user doesn't also have prefers reduced motion media query, have the prefers reduced motion media query set to reduce. You can use the same window.matchMedia API for this. For an example, that also includes using the save data header that I mentioned earlier directly in JavaScript. Check the blog post that I wrote on this topic at bit.ly/prefers reduced data. So that's a few ways you can use prefers reduced data right now that will automatically make your site perform better for users once support lands. I hope you start experimenting with this now, since that's a signal for browsers that this is something people want. You can use Polypane to quickly test both your regular and reduced data versions side by side. If you want, you can start a free trial at polypane.app. I'm on Twitter as at Kilian Valkhof and at Polypane. So feel free to reach out with comments or questions.
Awesome. Thank you so much. That was a really great talk. I learned a lot about accessibility for those who prefer less data, and also I didn't know there was even like a reduced motion. Did you say a header or a query?
That's a media query as well. Yeah.
Oh, awesome. That's so cool. I didn't even know about that. That's so cool. I was wondering actually, for start off, are these snippets that you provided available online somewhere? Do you have a GitHub or a gist or something?
So most of them are in that blog post I linked.
Oh, cool.
And I can also copy that in the Twitch chat
cool.
after this.
Yeah, that sounds great.
The only thing that's not in there that I figure out for this article specifically is the figuring out if there is support at all. So I'll make sure that gets added to the article in the next few days.
Yeah, that'd be great. Yeah, actually, I was wondering, when do you think this media query will become supported? Is there a timeline on that, or?
I haven't been able to find a timeline. The media query is fully spec'd out. Chrome already has an implementation behind the flag. From my understanding, what we're waiting on right now is whether or not there are potential privacy implications. They're looking at that now.
Okay.
I don't see any particular privacy implications compared to other media queries that we already have, but it's good that they check this before adding it for wide availability.
Yeah, everyone likes a little bit of due diligence. Yeah, no, this is really awesome. Thank you so much for doing this talk. Yeah, sorry, I just learned a lot. I'm still processing quite a lot about it. I think I'm going to have to start going through and auditing my own websites to make sure I'm up to speed for when it drops, or when people need this. Who do you think actually will benefit the most from this? Is there a particular type of person, or? So,
I mentioned two pretty big situations. So either you have like a monthly data cap, or you have very slow internet.
Okay.
And very, of course, is a little dependent on your own experience. But if you look at the majority of the internet users right now, that's not people like you and me. That's not people in the Western world using, MacBooks on 100 megabytes internet connection. That's people on often feature phones or very cheap Android phones with very poor networks. And the interesting thing is that if you think about this, if you implement it well, it doesn't just mean that your site gets loaded faster, which is nice, but it also means that people can actually access your site for the first time, because before it would have timed out and it would have taken 5 minutes to download, and now they can get to the content in the first place, which I think is like the biggest benefit.
Yeah, very much so. We just had a question in the chat. So if users decide that for a particular site they're willing to override that setting and load more data, is there a way to set that, maybe dynamically with the JavaScript?
You could choose to implement it however you want. More or less the same as with dark mode. So dark mode right now has a media query you can use, but a lot of sites choose to let people override that.
Okay,
with like a dark light mode toggle. And it remains to be seen how this feature will be implemented in browsers. Right now, the save data header that I mentioned is already available in Google Chrome for Android, where it's just a check mark in the settings. So in the settings, there's a check mark that's like turn on data preserving features. Okay. And I assume that this will hook into the same check mark.
Okay, cool. Well, thank you so much for your time today in the presentation. I learned so much. We're going to be taking a small break now, but up after that will be Sakshi Raina with a talk about microservice architecture. It's not just a buzzword, and we should talk about it more. So looking forward to that, and I'll see you all in about 15-20 minutes. Bye.
Hello, everyone. I'm so excited to be here in the ShortStack Con today. I'm Sakshi, and I'm currently working as a software engineer in a fintech company. Lately, I've seen that either companies have already adopted microservices or are rushing to do so. It's such a buzzword in the industry today, but also quite misunderstood. Either we don't quite understand what microservices are, or we don't know when to build one. The question that I want to ask today is this. Do we really want to move towards a microservice-based architecture because of the benefit it provides, or are we just trying to jump on the bandwagon? Some of the big companies today have adopted microservices: Amazon, Netflix, LinkedIn, Uber, Twitter, Spotify, the apps that are such an essential part of our daily lives. These companies have not only just adopted the microservice architecture, but embraced it, citing that they have seen incredible growth and are able to scale better than ever before. So before we see why do they think it's better, let's first discuss what is a monolith. And this is the first thing that comes up to my mind when I think of a monolith, right? A system in which all code is deployed as a single process connected to probably a database. We can then have multiple instances of this process for scaling purposes. So a monolith is basically just a unit of deployment when all functionalities in a system has to be deployed together. And these monoliths can take various forms. The single process monolith, which we just saw in the diagram prior to this. The modular monolith, where the single process consists of separate modules, which you can then work on independently, but then you still have to deploy them together. And the last is the distributed monolith, where we have multiple services, but the entire system has to be deployed together. Microservices, on the other hand, are independently deployable, which are modeled around a business domain. So two keywords here. First, they are independently deployable. That means a change in one service won't affect the other. And second, that they are modeled around a business domain, which brings with it a set of benefits of domain-driven design that we don't have time for today. Both of these are very two different architectural styles having their own pros and cons. But these days, some people use the word monolith quite interchangeably with legacy systems. I've had people come up to me and say, hey, our architecture is this way, and it's quite a big monolith because it's a legacy system. So now, although I do understand where they're coming from, monolithic approach is just an architectural choice, just like any other. It still might be an appropriate choice for some use cases, and it might not work for others, which is also true for microservice-based architecture. Isn't a one-size-fits-all strategy. It's a conscious decision that you make for your own use case, for your own system. For example, monolithic architecture works really well for people in startups who just started their business, and the business domains is not really clear yet. The business is still evolving. Also helps when your team size is small, or if you just want to create a simple application to validate your use case, like a proof of concept, doesn't need the complexity of microservices. Having said that, monolith also do come up with their challenges. Because it's a single unit of deployment, you have to redeploy the entire application, even if you change a few lines of code, making it tightly coupled. Since we also tend to put all kinds of related and unrelated code in the same place, monoliths tend to have no cohesion. It also isn't as resilient because just a single bug can potentially bring the entire application down. If you're in a big organization and you have a lot of people working in the same code, they can get into each other's ways. This applies to developers having merge conflicts or delay in approving pull requests, but it can also apply to the business. When you have all kinds of business functionality in the same application, you might also have different business owners, and they might or might not agree with the product backlog or the release timings, which can also slow time to market, and that is in the scalable solution. So should you then move to microservices because of all the things I just mentioned? Or if you'll ask me why should you move to microservices, my answer to that would be move to a microservice-based approach if you're facing problems that you cannot solve with your current piece of architecture. One reason for that could be to improve team autonomy. So as I just mentioned, developers and business owners can get into each other's ways. When you think about it, this is just blurred lines of ownership. Having a microservice-based approach can improve team autonomy. Keeping the organization team small has its advantages. They're tightly knit, they don't have a lot of bureaucracy, and they have the power and the responsibilities to make their own decisions. You could also then use it to reduce time to market by being able to make and deploy changes to individual microservices without having to wait for approvals or coordinated releases. We potentially have the power to release functionalities to our customers much more faster. These individual microservices can also then be scaled independently, which can help us to cost effectively scale. That means scaling up only those components that is currently not able to handle load, following up with scaling down the components which are under less load, or potentially even just turning them off when they're not required. That gives us so much more control over operational costs. You can also use it to improve robustness. So since functionality is decomposed, an impact on one area won't bring down the whole system. We can then focus our time and energy on the components that does require us to fix things, while still having the confidence that the other part of the business is functional, operational, and untouched. But as it is rightly said, microservices also isn't just a free lunch. It comes up with its own set of trade-offs. The biggest trade-off being just the fact that it's a distributed system, and distributed systems are complex. Since this is based on a service-oriented architecture, we have to deal with how these systems talk and interact with each other over a network. So we have to deal with latencies. Latencies can vary, making the systems unpredictable. Network packets can get lost, and network calls can also fail. We also have to deal with consistency of data to ensure that each node has the same understanding of the data in hand. Since microservices has a decentralized data system, transactions on data is also distributed, which can cause consistency issues. So we need to figure out how to detect when data is out of sync and then perform operations accordingly. We might also have to worry about the operational complexity, having to manage a large number of services, their deployments, monitoring, debugging. Without the slowly rising culture of DevOps would be a nightmare to manage. So if there is just one thing that I would want you to take away from this talk is to not see monolith as bad or microservices as good. Both of them are different architectural patterns that you can decide to choose based upon your use case. Microservices shouldn't be the end goal. It should never be the end goal. The understanding that you get successful or you win just by having microservices is simply not true. You need to know what problem you're trying to solve and then tackle that problem using the microservices approach. If you just break down your monolith into 20 different microservices without addressing the problem in hand, well, you just created that problem 20 times over. Be mindful, be conscious of the decision. Also, as James Lewis says, and I quote, microservices buys you options. The word buy here is deliberate, meaning that it has a cost. These are the trade-offs, and then you have to decide whether the cost is worth doing it now and then over again. I think that's me. I would love to take any more questions.
Awesome. Wonderful talk. Really loved it. I really loved understanding the trade-offs, like that monolith and microservices were not these kind of like neither one is perfect and they both have trade-offs. And I really liked your point at the end where it's like if you have a problem, moving to microservices will just will create it 20 times over. That's a very good point. I was wondering, out of the three reasons why for microservices, which were robustness, autonomy, and deploy time, Do you have a favorite one that's like very beneficial over the others?
If I have to choose one, I think I would pick team autonomy.
Oh, yeah.
Also because I think this is also causes a lot of problems in the long run. Because as I said, when you have a lot of business functionalities and also technical people in the same piece of code, there's bloodlines of ownership. So you don't know who to contact and what to do. You don't really gel around with each other. So what do? You just create more chaos in the end. So it's important that you distribute the services with clear business boundaries, have their own separate owners, and give more power and responsibilities to that system and the set of owners so that they can just make the decisions on their own. It would then also help with the second and the third point of saying that.
Yeah. Oh, that makes total sense. I think team autonomy is very important, especially as you grow as a company, knowing that people are self-sufficient and that you don't have to rely on specific teams or whatever to get your product deployed or maintained or whatever is a very good point. I was actually wondering about, so you mentioned that obviously they're both not perfect and they both have different use cases and problems. Is there a particular use case or problem that monoliths solve really well that you would recommend a monolith for? Does that make sense? Sorry, I rambled around the question a bit. Yeah.
Yeah, I think monoliths works really well for people in startups again because they are still evolving. They still are trying to understand what the business domain is, and they are still trying to understand how the business will evolve. So since they don't have a clear understanding of the business domains, it works really well for people in startups. Once you evolve the company, it makes sense. Also because if you start with a microservice-based approach when you are still evolving, you might have to just rework all over again once you have a better understanding. So start with the monolith first, and then it's an iterative process of understanding your business and then moving your system towards in that direction as well.
Yeah, I like that. An iterative process is a very good point. I think that those are all my questions. You were very good at explaining everything, so thank you so much. Up next, we'll be having Bunmi Akinremi, who will be talking about why we need more women in tech. She's going to go through some reasons. Hey all, it looks like Bunmi is having some connection issues and can't join us right now. So what I'll do is I'll wait out for her for another couple of minutes, but I'll put up the next talk and we'll intro the next talk, which will be give me a second, sorry, from Patrick Cormac English, Listening Like a Human. It's going to talk about some of the overarching tensions between use cases in ASR and the specific interactions with individuals. It's due to be a very good talk, and I'm really looking forward to it. I'll talk to you all soon. Hey, Bunmi, can you hear me? I can hear you. Can you hear me? Hello? Can you hear me? I... Yeah, okay.
Great. Me, and I'll be talking to you about why we need more women in tech. So, here's a brief intro about me. I'm currently a data scientist and also an Android developer, and I'm passionate about bringing more women into tech. And I'm also currently Zindi mentor. Zindi is a platform, the first data science platform in Africa for hosting competitions and hackathons. And I've been in the tech field for 3 years, um, still a computer science undergraduate at Obafemi University. And that was also currently published in a book titled The Techie Chick by Ibuku Oginaike. You can check it out. So straight to my talk. I'll be giving 3 reasons. I'll be giving reasons why percentage of women in tech is low and why some women start and stop halfway. I would also be talking about potentials and perspectives that women can bring into tech. I would also be giving examples of women who are change makers in tech and why we need more of them. So why is the percentage of women in tech low? According to this research by Core, you can see that there's really a low percentage of women in STEM roles, women in studying STEM courses, and those who would even, like to take a career in tech. And about 82% of these women don't even know female role models in tech. So yeah, tech is hard, but guess what? You're tougher. And let's be sincere, hard things really, bring out that beauty and innovation in you. And I especially like this quote by Eleanor Roosevelt that says, a woman is like a tea bag. You never know how strong she is until she gets in hot water. This is super true. This is so true. You're not weak. You're not weak. You're so strong. You're a strong and powerful woman. And, being in tech really brings out that innovation in you. Another reason is that there are very few mentors that you can easily reach out to. If you talk about in smaller communities, there are really few female mentors, I would say, and it feels totally different when you're talking to a female mentor than when you're talking to a male mentor, because you know that this person has passed through something I'm facing. This person has gone through something I'm going through, and she's the best person really to give me advice and tips. And also, as a woman, you might be very passionate about this tech career you've chosen, but lo and behold, you only find very few role models you can look up to as a source of inspiration and motivation. And this can also be a deterrent for women. Another reason is that tech jobs are way unattractive to women. Yes, not everyone likes technical stuff. Not all women like to code. Not all women like to write programs. But actually, there are other non-technical jobs in tech, like product managers, human resource managers, research analysts, marketing managers, and others that you can also see to. And this part is totally one part that cannot be overemphasized. While I was growing up, I had this younger brother who built this electric car, and I was so excited. Really, I wanted to know how he built it. I wanted to know how he went about it. And what he told me was that I should go and play with the dogs. That technical stuff are for the boys. I was so pissed and I was so angry. And you see, it's not really its fault. It's not his fault. The society has made us believe that technical world is for guys, and that's totally wrong. As an inspired tech lady, just disregard such stereotypes and biases and just go for what you want. Go for what you want. Don't let these stereotypes, don't let these biases, hinder you. And one day you'll be a role model and a source of inspiration, to other women. So why do some women start and stop halfway? In a research by Capital One, they found out that organizations have non-inclusive work cultures. There's no mentorship. Women feel undervalued, and women not being able to balance their life and family. And balancing your work, balancing family, it's very difficult, and not all women has been able to draw this balance, especially because there's no mentorship, there's no guidance, no motivation of some sort. Even some companies make women feel undervalued, and this is why some women just quit. And what are the potentials and perspectives that women can bring into tech? You know, I once saw this picture with two scenes. The first scene, there was a man and his son. They were both looking hungry. Everyone was looking dull. The home was looking untidy. And in the other scene, I saw a happy man. I saw a happy child. They were looking happy, and the home was clean. And guess what? A woman was around. And what this picture really depicts is that having a woman, in an organization, in a board, really brings out, new ideas, bring out, refurbish existing ideas, and make more impact. Women could build a more balanced data system with a much longer term view on how the solutions can create positive impacts. Diverse problem also, would require diverse perspective to solve them. You can't expect, to solve a problem of diversity and then you're only biased towards a particular gender or a particular color. So let me talk about some examples of women who are change makers in tech. I'll talk about Ada Lovelace. Ada was an English mathematician and a writer, and she was chiefly known for her work on Charles Babbage mechanical engine. And it was a general purpose computer that is called the analytical engine. And she was the first to recognize that this machine, had applications beyond pure calculation. And she was the first to publish the algorithm that was carried out by such a machine. And as a result, she's often referred to as the first computer programmer. There are also other ladies, but I would also like to talk about Sheryl Sandberg. She served as the chief operating officer at Facebook, and she's been there since 2008. And the impact she has been able to make is that she has been able to dramatically increase the social media's firm revenue. I focused on positioning Facebook as a platform for small business advertising, helped increase the ad revenue by 27%. During 2019. Another really inspiring woman to me is Joanne Shotwell. She's so inspiring. She's an American businesswoman and she's also a mechanical engineer. And currently, she's the president and chief operating officer of SpaceX. And she's responsible for the day-to-day operations and company growth. What inspires me about her story is that she went from being a mechanical engineer, a mechanical engineer graduate, to being one of the two principal voices at SpaceX. And she was able to convince Elon Musk that SpaceX should hire a dedicated employee who would work on business development full time. And although during that time she visited the company, she was not ready, but her impact in SpaceX, is very, very inspiring. She's been able to she's been able to sign a contract with NASA, to deliver, supplies, and that's really, really inspiring. So we need more of these women. We really need more of them. And some reasons are the fact that, as I said earlier, you can't solve gender issues by being biased with your chosen category. So if you want to solve gender issues, you obviously need more women. So women would obviously provide a more balanced view to female gender and technology issues, and you would even have more revenue. The more diverse your product is, the more diverse your software is, the more diverse your products are, the more customers you would have, because women and other genders, will be able to, use them. And most importantly, overall, we need more role models. We need more women to impact more women. We need more role models. And I'll be leaving you with this quote, make conscious efforts to keep a woman, to help a woman who would help another woman stay in tech. In everything we do, we should be genuine. We should be conscious. We should not just be doing it, just not be saying it, not just by words, but really in our actions really should show that we are making conscious efforts to help women stay in tech. Thank you.
Thank you so much, Bunmi. That was wonderful. Really insightful talk. I learned a lot. We'll be moving almost directly on to Cormac now. and I'll be back in a minute.
Hello. Okay. Hello, everyone. So thank you very much for coming along. So my name is Patrick Cormac English, and this is Listening Like a Human. So just to get kicked off, a very brief introduction to me. I'm currently a DReal PhD researcher inside UCD at the moment. My focus at the moment is accented speech and automatic speech recognition systems. I wasn't always a computer scientist. Actually, I transferred over from law. So I did my undergraduate in UCD a couple of years ago and then did the Masters of Science Conversion in UCD as well because I'm very unimaginative. So that's, I suppose that's get you set up. On top of that, an even quicker introduction to what this talk is going to be about. So very briefly, I'm just going to say like what we're doing. So what is ASR? What are we trying to achieve? How we're doing it. So a very quick rundown on roughly where we are at the moment in terms of state of the art and why it doesn't always work. So that's kind of the key takeaway from this talk. So to get going, here's an incredibly brief history of ASR. So it's actually a very old field. It's been around since the 1950s. And just to explain what you're seeing on the right-hand side of the screen here, you'll see basically what you're looking at are what's known as spectrograms. So these are basically graphing power levels at different frequencies. So we use them a lot because they're a great way to capture a complete view of human speech. Now, underneath these, you'll see little characters, and they are referring to phonemes in English. For this set anyway. So basically a phoneme is a contrastive unit within a given language. So basically if you imagine dog and Doug, the O and the U, you have two different types of phonemes there, right? So it's important that these things contrast with each other. Now people don't always produce like a perfect representation of a phoneme. We're going to just produce what's known as a phone, a given sound, and then we kind of match it up to the closest one. But you can see there, just to be aware that it's important that these contrast. You'll also see that a lot of these look pretty similar, which is a problem we'll come back to later. But basically speaking, we have been moving from like identifying back in the 50s very simple sequences, like maybe matching the closest spectrogram to, or these clusters are known as formants, matching formants to like the word 1, 2. I think the first one was a machine called Audrey that could do 0 through 9 and plus and minus, a very simple mathematical thing. As time went on, the vocabulary started getting bigger. You 16 to 30 words through the 60s. By the 90s, you had very big vocabulary, so big databases of kind of idealized representations of words that we could try to match to what's coming in. Very stilted, easy to break, didn't account much for kind of the I suppose the little minutiae of human articulation, and certainly didn't account for like inter-word interaction, that kind of thing. Today, I'm sure any of you in the tech sector are probably not going to be surprised. It's deep learning all the way. So we have very large deep learning networks at the moment. So, you know, trained hundreds of GPUs, millions of sound utterances. It takes weeks to train, you know, very large, huge data sets, very capable relative to their predecessors in terms of correctly identifying sounds. So just to give you a very brief rundown, so this is a picture taken from the WAV2Vec 2.0 paper, so that came out about a year ago. So WAV2Vec 2.0 is out of Facebook. It's quite a novel architecture insofar as the main training stage is focused on just trying to identify the sound units within a language, and then later on learning to map them back to characters and things. So typically speaking, there's usually a couple of layers in terms of when we're trying to understand speech. So there's the audio layer, trying to, well, what does this audio sequence, however it's represented as an image, as a vector, what does that map to? And then a language layer where we'll try to impute language context to what we're hearing. Like if we go 3, 2, 1, hero, we might say, well, it's much more likely that we heard 0, you know, that kind of thing. Now that causes problems on its own, but we have been getting more and more complicated. So this model is enormous, and it's also end to end. So that was a big thing. Stop treating it as kind of separate tasks and just give the data set over to a correctly designed model and hope that it's able to drag out the various patterns therein. And it does make it much more robust. It's much better at handling like the little slurs or you know, improper articulations that humans make all the time. So seems great, wonderful stuff. We've got great metrics coming out. Things are you know, 94% correct, that kind of thing. But it doesn't work a lot of the time, as I'm sure most of you will have noticed. So I've given a couple of very glib examples on the left here, but you know, very simple things like single individual words just not being picked up no matter how much you talk to it, and that's actually something we'll come back to as well. This idea of responsiveness, you know, things claiming, as I said, 94% correctness, but then when they go into a production environment on an accented data set or something, everything falls apart, and suddenly you're running 80% correctness, 1 in every 5 words, so to speak, not being heard correctly, and so forth. So what's the problem? We don't know. No, I'm joking. We do know, but the problem is that knowing doesn't necessarily give us a very easy path to actually understanding or to resolving this issue. So at a very basic level, we are working with an enormously diverse set of data. So it's the unique sound production values of every human on Earth, because these systems are always generally interacting on a one-to-one basis. They're not talking to South Tipperary accent, they're talking to me. They're not talking to Glaswegian accent, they're talking to a person in Glasgow. So we end up with just an enormous amount of deviation within a given language, right? So we have accents. Within that, we have different types of accents. We have regional variations. We have L2 variations. So people bringing over patterns of enunciation from their first language, if it's the second language they speak, or the third language, or so on. And realistically, the scale of this can't really be understated. There are 7,000 languages being spoken at the moment within that infinite variation accents. So what has tended to happen, and it's very obvious when interacting with most of these systems, what has tended to happen is that we've ended up with high resource languages, high resource accents. So these usually map pretty closely, I would say, to what you might expect in terms of societal predispositions. So English is a high resource language, shocking nobody. And within English, then things like San Francisco Bay accent, very high resource. A lot of American accents are very well recognized. And then as the groups you're dealing with get smaller, and I say small here, we could be talking millions of people. That's still a small group. The quality of the data provided to the model and the representative nature of that data is getting smaller and smaller and smaller. And suddenly it's experiencing patterns of articulation and sound production that it's never seen. And it can only approximate, right? This is all only about approximation. So just to click on then, you might think, well, okay, that's fine, but humans do this. Humans listen all the time and understand language all the time. There doesn't seem to be that much of a problem. And that's true, But that's because humans are really, really good at this, right? So humans, first and foremost, we do something called perceptual learning. That's not something any of our networks really do. So perceptual learning basically means that I can be talking to someone, I can be in Normandy and talking to someone with a heavy Northern French accent, and they will have patterns of sound production that I don't understand too well. It's a phenomena that it will only take a couple of interactions for me to take these exemplars and really quickly evolve my understanding internally, my representation of if they're saying dog or things like that. I'm going to very quickly adapt to accommodate them, and vice versa. And similarly, if I go to talk to someone else from the area who's a similar accent but not the exact same patterns of sound production, I can bring those things over. So that's one thing, and we'll talk a little bit about that in a minute. But on top of that, humans have simply immense correctional ability. We can draw context from audio, from language, from conversational context, from personal interaction context. We have so many ways to repair defective, so to speak, audio coming in. If someone doesn't finish a word, I can probably guess what word they're going to say, and we can just move on, and I will do that subconsciously. To put it, I've written it there a bit glibly, generalized intelligence. We are, as we understand, a general intelligence. I can come in from so many vectors in terms of solving the problem. I'm not limited to one tool set. So in terms of what's going forward, I'll actually jump onto the next slide just to show you an example. It's not as dire necessarily as I make it seem, because we are trying very interesting things. So this is one example I saw about a year ago, whereby I think it was Mandarin Chinese. They were attempting to use a particular architecture to strip out accent-specific data from a particular piece of sound production, and separate that from the deviations or not the deviations, the patterns in the sound that were related to the underlying language. So try to take the word away from the accent, if you'd imagine it. Now, I'll be frank, and you can kind of see looking at this, it didn't really work. It kind of mangles it. And to be honest with you, it's probably a little linguistically suspect to be trying to disentangle accent and language, because they don't really come apart that cleanly. But we are trying novel things. So what's the timeline? We're not really sure. Perhaps we'll start moving towards few-shot models that are very interactive. So we'll have these models where you talk to them, you correct them, they develop some sort of a data unit for you that corrects for your speech, so maybe a layer on top of the network that corrects for you. Most likely, we'll probably just keep getting bigger and bigger data sets and more advanced model architectures, and they'll get a bit better. But it's still very much an open question, and it remains to be seen how much can be resolved just by throwing bigger data at it. You can ignore the magic. I left it there because PowerPoint put a unicorn beside it. So that concludes. Thank you very much, and thank you to the organizers of this event. I've made sure to thank them there so I can't forget.
Thanks very much.
No problem.
That was a really great talk. That is a lot more about speech recognition than I ever knew. It's very interesting.
That was actually one of the challenges of this, was thinking, well, how much are people going to know coming into this? Because you start hearing things over and over again, and you go, well, everyone must have heard of this, but it's not necessarily true.
No, it's very true. So you mentioned that we have this ability to repair the audio. Is that something we could eventually approximate in our models, or is it too far?
Look, it's absolutely something we want to do, and there is this old saying that airplanes don't flap their wings. It's not necessarily the case that we have to copy what humans do in order to complete the same task. But at the moment, one of the biggest developments in recent years was this idea of transformer architecture that has an attention mechanism that basically means that inside, as it's weighing up things, it can take context from around it. So it can take context from the surrounding audio rather than just being bombarded with the context from the whole utterance. Now, that was huge, and it has made things a lot better. So there's nothing to say that we won't be able to incorporate more and better versions of that. Maybe in 10, 20 years' time, with the computational power we have available, we'll have very advanced AIs that are capable of kind of fixing themselves on the fly, taking information from the surrounding conversation, imputing that. There's nothing necessarily preventing us, except at the moment, I suppose, limits of computation. But at this, but at the same point in time, we're also a little bit constrained in terms of what we know about how humans perform these processes. We do have fairly big old brains, and sometimes we can kind of get blown away by how great our models are, how fantastic they're performing. But at the same time, they're very limited. So It's all up in the air. I know this sounds a little bit disappointing. I'm sure people are hoping for me to swing in with an answer, but I was actually talking to a colleague during the week, and he looked up at me and he said, "Cormac, I've been doing this for 5 years. This might actually be impossible." So that's one side of things, but I think it is interesting to think about anyway.
Yeah, very much so. I mean, we do still need people to figure out if it is impossible. That's still very important.
That's absolutely, anyone doing a PhD, it's fine if you fail. That's a valid data point.
I'm glad we pivoted into motivational speaking now. I guess tangentially, you mentioned specifically about like in Mandarin stripping out the accent. Is there anything else that's kind of on the horizon of things that are very popular that we're trying now that could be achievable soon?
In terms of things on the horizon, so that was one random one. Another one I've seen is this idea of a few-shot model. So some sort of model that takes and adapts very quickly to novel exemplars or examples, basically. Cut the jargon. That they receive in a given piece of speech. So maybe it's something we'll see going through. A lot of people I've spoken to in the field are a little bit hesitant about this because back in the day, in the 90s, you used to have to actually train up these models on your speech. So now that was because they were terrible. But to a lot of people, that kind of harks back to that. So there wasn't, I've brought this up in a couple of conferences. There isn't an enormous appetite to have these models go back to having to talking to you. But at the same time, this is, I mentioned there, this kind of golden rule. You know, if someone is saying Doug to me, and you know, I haven't spoken to them before, there's no way to know what they're actually saying. Are they saying dog? Are they saying Doug? I can put in like language context, which is a big thing that we've been doing. So language context has been huge, and end-to-end models have made that language context much more robust. But at the same time, you know, what you don't know, you can't predict. So you might need that interactivity. I'm not sure.
Okay. Well, that was very insightful. Thank you so much.
No problem at all.
Yeah, thank you again. And yeah, I am muted. Sorry. So we're going into a bit of a longer break. It'll be about like 35, 40 minutes. And after the break, we'll have Greg Bohr, who will be talking about the iron triangle of software delivery. So it's going to go into why we see more and more glaring software bugs and security breaches all around us, and why our engineering ethics rarely discussed in our profession. I'm super looking forward to it. And after the break, we'll hear from the man himself. Thanks so much, and I'll talk to you soon.
Hello everyone, my name is Greg Bohr, and today I will talk a bit about the iron triangle in software engineering and software delivery, and a little bit about myself. So I am in the tech ecosystem for the last 20 years. I have done quite some things that I enjoyed, and also to note, what I will present is my opinion, so my observations about what I have seen. Your mileage may vary, and that's totally fine. Your experiences might or may be different, and that's also totally fine. So just sharing what I have observed. So what I have observed, what have I observed? Software's impact is increasing. Just in the last 30 years, many people in the world have just one device always in their pocket. Most households have 2, 3, 4, I don't know how many devices with their own operating systems and their own software stack. And these devices hold more and more sensitive data. So our own family photos, our documents, our emails are held by computer systems. However, these computer systems have bugs. The operating systems have bugs, the software stack have bugs, and these bugs and breaches are getting bigger as the impact of software is getting bigger. Just lately in Ireland, I don't know how many of you are from outside of Ireland, basically, our healthcare data has been stolen by hackers, and that's not great. I mean, everything, as far as I know. If you ask people about how they would feel about this 30 years ago, their whole medical history landing in the hackers' hands, they would probably be uncomfortable. I am uncomfortable, and that's just what we have at the moment. Now, what could help is usually back pressure. So what could motivate engineers and companies to do a better job? Market, for instance, does the market provide pressure on companies and engineers? I mean, do companies go bust? Do their stock hit the ground and not recover? No. So there is, I mean, they are affected a bit, but there is not a lot of back pressure from the market. Users rarely switch providers after hacks and breaches. Law enforcement. Do police men and police women go after criminals and put them in jail? I mean, they do to a certain extent. They are doing the best job they can, but they aren't seem to be have set up for success. Laws and regulations are quite fragmented over the world. They are underfunded, under-resourced. So, I mean, there's not a lot of back pressure from that angle. Regulators. Do we have helpful regulations in progress? I mean, looking at a couple of houses just outside, every house I see has a responsible builder and a responsible architect. So if something happens, there is someone accountable because of regulations that the architects have in their craft, in their profession. Are we advancing in tech? Not really. So not a lot of back pressure from there. Now, what do tech companies do? They do something, but honestly, I'm not seeing game-changing behavior changes from their side, unfortunately. Some do quite well, by the way. So the trend, I'm a bit concerned about the trend of software getting bigger in the world and quality just not being great, and data often private and personal data often leaking. So what's going on? To be fair, our software engineering discipline is like what, 60 years old. Approx architecture is thousands of years old, so it really had time to mature. We didn't. It's just a young discipline, so it needs to mature. Now, in 10 minutes, I cannot cover all the pain points, but I can cover one pain point. It's called the iron triangle. Now, the concept is quite simple. If you want to do something, then it needs some amount of time to do it, and there will be a cost associated. It's really that simple. So if a desk manufacturer would like to manufacture this desk, which is the scope, it will take a couple of days, that's the time, and it will cost some money, and the wage of the employee who is manufacturing that desk. Really simple, and software isn't very different from that. If we want to do a couple of features, it will that's the scope on a certain level of quality. It will take a certain amount of time, and the cost is represented by the wage of the software engineers. So so far so good. But software has a unique or a reasonably unique attribute. Quality can be postponed. Things can be postponed, and we will see how this affects software quality. So how the hammers, where are the hammers? So the pressure is coming in on software projects. Companies like to save money. There is pressure on cost. Companies like to race with other companies, and the market pressure is quite all right. So there is usually pressure on the time under which certain feature set is going to be delivered. And good companies just say, okay, there is I can't spend 2 weeks on a certain project. I can only spend 1 week. Fine, I will just deliver not 10 features, just 5 features, and that's totally fine. No problem. In our young discipline, what can happen is that the number of features aren't significantly reduced. Something else is reduced, and here comes trouble. So what can be also reduced? Code quality, even process. So certain helpful processes just not being set up. Security can be reduced, and pressure can be put on people even. So. We all know that sometimes there is high pressure projects where we just work a lot, and that does create a certain depth. Now, what I have seen is that these depths are so we can imagine a golden credit card handed out to every software team in the world, where they can relatively freely put technical depth, all the different kinds of depths. So half or poorly scoped features where just the scoping did not happen, or bad code quality, processes that have not been set up, or people pushed towards burnout. And also security tests just not being done. All these can be collected on this really nice golden credit card that at some places just don't have an owner. And people, in some places, there can be dynamics around it where certain people benefit from it, and it's going to be someone else's problem later down the road on a different team. However, there are good signals, so you can watch out for good signals in technology teams. For instance, if the depth is taken on a smart way, I think that most companies and most teams should go for some technical depth, but in a smart way where the depth is limited, it's visible, it's tackled, so there's actually investment made into reducing that depth a long time, and so expectations are adjusted towards the team members. If there's a lot of tech depth, they can probably just go around the business slower and develop new features slower in a code base that is a bit shaky. So what can we do? I think we can do a couple of things. I think we will need more discussions around it, both around how the market can positively influence software quality, how regulations maybe could influence positively the software quality, engineers' representation, how they can unite and how they can achieve ways on getting to a good software quality around delivery, and just maybe a bit more talk around engineering ethics would be a good idea. What we can do every day. So important to underline when appropriate. So I'm not saying that you should do these things. You should maybe consider these things if it's appropriate in your environment based on your status currently in the organization and in the team. So what can be considered when the pressure comes? Just offer fewer features to be delivered with the right so explaining the rationale behind it, linking to software quality. We could propose this stuff to be included in university education. The team can agree to just do it and just ship things with good quality. The depths can be quantified, so it's easier to communicate. The effects could be communicated, and I am out of time. So just for moving to the takeaways, our discipline is young, so it's okay that we are seeing challenges. Please don't postpone quality or security, please, for the love of the globe's population. And I think that this is on us, so we need to find a solution for that, no pressure. So that was pretty much my talk about this topic today, and I will be happy to answer a couple of questions should they arise.
Yeah, no, that was a really great talk. I learned a lot about the kind of tug of war between the Iron Triangle and how they all kind of relate to each other, and how you can't optimize for one, or you can't optimize for two without making concessions in the third. It's a very good talk. I was actually wondering, you mentioned about making technical debt can be good if you make it visible. And I was wondering if you had any tips about making it visible, because that's often a very hard thing, I find anyway.
In practice, probably I would consider chatting with co-workers first, especially people who are in the organization for a bit longer time, who are good people to include in that conversation. Hopefully getting some sort of a buy-in from at least from one's line manager. And what can be done is to just do a spreadsheet and put items on it and put an estimation on approximately how much time it would need to fix those things, and do a little sum. After all, you can even translate it to money with a finger in the air estimation on the people's wage. That could be one way to start quantifying it. Also, what might help the businesses to understand as software delivery gets slower because of the technical debt, what are roadmap items that get probably less love and just not get done.
Yeah. Well, actually, that leads me on to another question I had, which was, do you find it hard to explain that balance and tug of war with the business side, who obviously have different priorities to the development side?
No. So in my experience, the business side is smart and simple. If we translate it in their language, then they are totally able to understand. They also have their priorities and they also have pressure on them. However, I think it's on us to communicate efficiently what is the effect, not just in quality, but how this how this snowball will grow and what it might impact later down the road.
Yeah, no, I think that makes total sense. Great. So thank you again for the talk. Up next, we're going to be having Marian Horgan, who is going to talk about her journey of growing a Raspberry with a Raspberry Pi. Fantastic, and we'll see you in about 5 minutes.
Hi, everyone. My name is Marian Horgan, and today I'm going to talk about one of my recent hobbies and how I tried to add technology to it. So last year, a lot of people took up new activities and hobbies when they found they had a little bit of extra time. So while a lot of people started baking sourdough bread, I began acquiring plants. And note how I use the word acquiring here rather than growing, because unfortunately, not all of them did grow. May my aloe vera rest in peace. So when this happened, this left me with a few questions. What went wrong? How can I prevent it from happening again? And which one of my housemates was overwatering the plants? But mainly, I wanted to know, how can I grow? How can I grow my plants better? Now, it might seem obvious that all you need is some water, sunlight, and heat to have a thriving plant, right? But I am a computer scientist first and a plant mom second. So I wanted data. And this is how the seed for my idea was planted in my head. If I could somehow monitor the watering of the plants, I would be able to relate how they were doing to how often they were being watered. And then taking this a step further, I wanted to make an experiment. I would take a few plants of the same variety, which happen to be my sunflowers, and have different watering conditions for each, such as hourly, daily, or maybe weekly, for instance. I would add a Raspberry Pi with some soil moisture sensors to track this data and display it on a nice dashboard. And to automate this, I plan to use my Raspberry Pi with a water pump. I figured with this information, I would find the answer to my question, how can I grow? There's this nice quote from Mary Tyler Moore that I find quite applicable here. Take chances, make mistakes, that's how you grow. Because that's exactly what happened. While I may not have grown the plants like how I wanted, I certainly grew from my mistakes. So one of the first issues I ran into was reading the soil moisture values. The output from the sensor was digital, meaning it was either 1 or 0. So the soil was either moist or not. As you can see, this is very limited data, and it wasn't particularly useful for what I wanted. What I needed instead was analog output. Both types of signals can be represented as waveforms, the difference being that analog waves are smooth and curvy and have an infinite value, whereas digital waves are like square and go in steps, so they're 1 or 0, on or off. Because the Raspberry Pi doesn't have any analog GPIO pin, I needed to get an ADC, an analog to digital converter. That way, I would have a meaningful measurement to test my hypotheses. Another issue I learned was that the type of sensor I had was a resistive soil moisture sensor. The issue with this type is that they're susceptible to corrosion over time because the electrical current sent between its two probes can cause electrolysis. The solution to this is to use a capacitive sensor instead. They don't have any exposed electrodes and are comparatively corrosion-free. Some say it's a good idea to put nail polish around the outside of it. I'm not sure how true that is, though. While not a technical problem, but still something that impeded my project was that sunflowers grow alarmingly fast. So I was not able to scale my project at the same rate of their growth. Thankfully, though, the sunflowers are doing very well, and they've just started to bloom. And also, it turns out that they like a lot of water. So while my first attempt at techifying was not quite the success I had hoped, I'm a big believer in learning from mistakes. And I thought I would take on everything I had learned and try again. So I bought a greenhouse. Go big or go home, right? This phase of my project is a work in progress, so I'll mainly tell you what I want to achieve. My big goal is to automate a greenhouse with a Raspberry Pi for hydroponic gardening and grow a raspberry. If you can't tell already, I'm a big fan of puns. And for those that are even newer to this than me, what's a hydroponic system, right? So hydroponics is a type of horticulture that involves growing plants without soil. So instead it uses nutrients in the water. There's about 6 or 7 types to choose from. The simplest is the wick system. This doesn't require any electricity, aerators, or pumps. But the system I chose for my project is a drip hydroponic. In this system, the nutrient solution is pumped to the base of the plant, and this lets it trickle down over the root system. As there is no soil, you need a medium for root support, such as perlite, rockwool, or clay. This is my roadmap of my plans. So right now I am doing mixtures of step 1, 2, and 3. My greenhouse arrived recently, but it's yet to be set up. I'm also trying to repurpose materials from my home to construct my hydroponic setup. All you really need is a basin or a bucket to act as the reservoir, and this is where the water with the nutrients is stored. And then a netted pot that has really good drainage to hold the plant, as well as a tray to elevate this over the water. In the meantime, on step 2, I've been working with sensors. So I have a BME 280 sensor, and this checks the temperature, humidity, and pressure. I also have a camera for visual monitoring, and I have an immersive water pump sensor. I'm also looking to get a pH sensor and a water temperature sensor. So all of these values are really important to monitor in order to have the right conditions to grow. But of course, the more parts you have, the more expensive it gets. So I'm going to do a little bit more research before I make that splurge. As for the dashboard, for the moment, I am using Python Flask to display the readings locally. And they're also being stored in an SQL-like database. But in the future, I'd like to try maybe existing IoT dashboards, possibly Blink or some others. And then, of course, my next step is to bring all the parts of this together and have a pretty basic hydroponics system set up. Learning from last time, it is better to have the system set up and debugged before you start the actual growing process. So only then will I transplant the raspberries to my hydroponic system. For a raspberry plant, it's better to start with an already growing one rather than sowing the seeds. And then as a stretch goal on number 5, I'd like to be able to control it remotely. It would be awesome if I could get it to automate regulating the environment, such as opening windows if the temperature got too high, or maybe even adding nutrients to the water. And of course, last but certainly not least, I'll be harvesting the raspberries, because nothing better than to reap what you sow. And after all, isn't the core of my project to grow? And of course, I can't do a talk on plant monitoring using a Raspberry Pi without mentioning GrowLab. So this initiative is something I found out about recently, so kudos to Evan for that. It's a really cool idea from Alex Ellis. So GrowLab is a global contest to grow seeds and share your progress with a Raspberry Pi. You can sign up to become a lab technician on their GitHub and take part. A really cool feature I found of the contest is to create a time lapse of the seedlings growth. I found it really fascinating to watch their growth throughout the day. They move so much, it's like they're dancing. And of course, there's been some common overlap with my own project, and it's been awesome to see how others take on the plant monitoring challenge. So that concludes my presentation. Thank you all for listening. Thanks to Evan and the event organizers for this opportunity today. And I hope you all feel inspired to start growing your own herbs and veg as well. So thank you. And any questions now?
Awesome talk. It was really great. There's a lot in there that I didn't know about, 1, growing plants, and 2, about sensors. Obviously in college we covered some sensors, so but I completely missed the fact that analog versus digital input would need a converter. That's a very good point.
Yeah, this is very new to me. I had never played with Raspberry Pi before, so of course I made lots of mistakes that are probably trivial to some experts out there.
Well, that's how you learn, isn't it? You got to start somewhere. Exactly. So actually you mentioned a couple of different routing materials, and I was wondering, what routing material did you end up going with?
Yeah, so there's a good few types out there, and they all kind of have different drainage. So I ended up mixing a few. One of them is perlite. I think perlite's made from volcanic rock, I heard. I might be wrong on that, but that's what I heard. And it has really good drainage, because raspberries, it's very important that the roots have good drainage, because they're susceptible for rot in the root.
Wow, okay. Very interesting. You got a piece of volcano in your project.
It's pretty cool.
Yeah, you mentioned Flask as well, and I was wondering, did something come pre-made for Flask, or did you write it yourself, or?
I'm only using the basic materials, and there's a library as well for showing on a graph. I can't remember that off the top of my head what it's called.
No worries. Okay, cool. And I was very interested to hear that you bought a greenhouse.
That was a big step.
Yeah, I can imagine. I was wondering, at what point did you decide that the greenhouse was the next step, and where does one buy a greenhouse?
Yeah, so technically it's not necessary to have a greenhouse for hydroponics. Like, hydroponics fit well in small environments. But I was kind of after getting really into this whole gardening and acquiring plants, and there just was not enough room in my house. So I made the move to buy a huge, like 18-meter squared greenhouse outside.
Wow, okay.
And we got it it's somewhere in Ireland, I think, Offaly or somewhere selling them.
And what beyond the sunflowers, what else, and the raspberries, what are you going to grow in the greenhouse?
I'd love to grow our own veg, so just roots like carrots and onions and even tomatoes. The idea is to be sustainable with our own veg and things. I think. Yeah, I'd love to go down that route. Hopefully they grow.
I'm looking forward to farmer Marian Horgan and her commune in the next couple of years.
Me too. Thanks, Evan.
Okay, well, thank you again. So up next, we are going to be having a talk from Thomas Creavin, who is going to be talking about the Pomodoro technique and how you can use it to increase your productivity. It's an app framework for dealing with open-ended tasks, and we're super excited to hear from Thomas about this in about 5 to 6 minutes. Okay, I'll see you all then.
Hi everyone, my name is Thomas Creavin. I'm a soon-to-be graduate of UCD Computer Science, and I'm a software engineer at Amazon. So welcome to my talk, Pomodoro in Practice. So most people know don't use any time management framework, so I thought I would highlight some of the merits of using one. Specifically, I want to encourage the use of the Pomodoro framework because it's reasonably straightforward and it's quite easy to stick to if you know how. So I'm going to give some tips on how you might implement it in such a way that you'd stick to it and you'd get the most use out of it. So I'm aiming this talk at those who've never tried a framework or maybe have given up on a framework, and specifically those who work on open-ended tasks like working on a large software project, writing reports, maybe your job as a whole. I'm focusing on open-ended tasks because they can be fraught with procrastination, they can be difficult to measure progress, or it can be hard to maintain motivation. So if you're using a more rigid framework, it's much easier to combat those. So without further ado, the Pomodoro framework. So the framework was invented by Francesco Cirillo in the 80s. It's a simple enough system where you work in short intervals of time and you take plenty of breaks in between. The name Pomodoro, it translates to tomato. So Pomodoro is Italian for tomato. So in his book, Francesco outlines a series of rules for using the framework, and we'll quickly go through those now. So the first rule is that when you start a Pomodoro or when you start to do a block of work, you do that work for 25 minutes. And during those 25 minutes, you work solely on the task. You're not going to check your phone, you're not going to answer the door, you're not going to be texting. You're just going to do that task for the full 25 minutes. After that time is up, you can take a break, do whatever you want, so long as it's not more work. When you complete 4 of those, then you're free to take maybe a 15 to 30 minute break. Each Pomodoro is indivisible, so you either have one or none. You don't do halves or 3/4 Pomodoros. It's one or nothing. So when you start a Pomodoro, it's not finished until the full 25 minutes are up. So even if you finished your task in 15, 20 minutes, keep going till the 25 minutes is up. So if you got time to spare, maybe you can review the work you've just done, or maybe you might want to get started on the next task. So this is the strictest rule, or the most difficult rule. If a Pomodoro is interrupted, you have to void it. So if you get up to answer the door, you have to scrap that Pomodoro. If you start going on Instagram or daydreaming, you scrap it. Rule number 7 is to protect the Pomodoro, meaning if you're doing work and you think of something to check out later, like, oh, I need to book my ticket to Irish Rail or this or that, write it down on a scrap of paper, come back to it later. If someone wants to talk to you, maybe tell them come back in 5-10 minutes when I've finished my task. This is probably easier to do in an office environment. When you're in home, you may not have that luxury. And finally, if your task takes less than 1 Pomodoro, maybe add up a few small ones. If it takes more than 5 to 7, break it down. So here's the life cycle of a Pomodoro. At the beginning of the day, you're going to list the tasks you need to do, make a series of estimates. You might want to set a timetable. By timetable, I mean you might decide, I want to do 5 Pomodoros before lunch, 3 Pomodoros after lunch, and then I'm done. I like to set a minimum amount of Pomodoros to do in a day. So I'll usually say to myself, I'm going to do 8 Pomodoros today. And if I at least do 8, I can be happy to finish at that or do more if I wish. So usually I write this down in a Google Keep note. So just to keep it nice and simple, I just use whatever's handy. So I write down the date, how many I want to do at a minimum. So here I've set, I want to do an assignment, a quiz, and work on my final year project. So in the curly brackets, I have the estimate in Pomodoros and how many I need to do. So once you're all set up, then you can start doing Pomodoros. When you start the timer, if you have any interruptions, maybe note them. Then you finish your Pomodoro. Once you finish, you update your progress. So if you've done a Pomodoro on an assignment, update that to 1. And then take your break. At the end of the day, it's usually worthwhile to review the work you've done. So maybe at the end of the day, this is what I might have. I can see here, I did all my InfoSec assignment. The spatial quiz took a bit longer. I didn't do as much of my final year projects as I wanted. And I did a lot of miscellaneous tasks that I didn't plan to do. So that's something to keep in mind for next time. So my experience using this, I got into it just for final year because I was working on my final year project and I felt I wasn't really getting anywhere, or it's hard to know if I was making any progress because it's such a large project. It's kind of never ending. You're going to be doing this for weeks and weeks and weeks. Using the Pomodoro system, it's quite easy to see that you're making progress. So I could see that by the fact that I was maybe doing 4 Pomodoros a day on it. And sometimes I give a breakdown of what each of those Pomodoros were. I found by using some sort of framework, I could use my phone less and procrastinate less. Because when I sat down to do work, I was doing nothing but that task. Then those 5 minutes, then you can check Instagram or whatever, Twitter. And it's good in those 5 minutes. Maybe something's actually happened for you to check out. It helps to focus on the tasks that are important. I noticed when I wasn't recording the task that's getting done, I neglected the harder tasks more than I realized. When you start writing down everything you do, I quickly saw that, okay, I love to do the easy tasks and I did a lot of work on those, but I was not doing any of my final year project or not doing any of this harder assignment. I found that I could finish work earlier. What I mean by that is I would say to myself, okay, if I do 12 Pomodoros, I'm going to stop at that. So sometimes if I'm up early, and I do my 12 Pomodoros by 2, 3 o'clock, I'd finish for the day. Sometimes I'd go to Galway in the middle of the day and finish the rest of the Pomodoros at night. But it took the pressure off because it was very clear of what you needed to get done versus saying, oh, I'm going to work from 9 to 5. Well, what does that mean? Because you could procrastinate for 2, 3 hours and not actually do anything productive. Using a framework, I found helped answer what I call the big questions. So what did I do today can be answered by, well, what did I spend those Pomodoros on? What tasks did I complete? Was I productive? Well, you can see if I worked on the tasks that mattered, then yes, I was. So in the example I gave earlier, I did a lot of miscellaneous tasks. So you might say maybe I wasn't that productive. I should have maybe worked on my final year project more. Did I work hard today? Well, that can be answered by, well, did I do the minimum? Did I do a bit more than that? And so on and so forth. So it helps you feel less guilty about the amount of work you need to do. So tips and advice. I like to work in Pomodoros of 20 minutes because that's probably the most my attention span can handle. I think that's kind of a nice duration. I take a break every few Pomodoros. If I feel a bit tired or if I feel I have more energy to keep going, then I'll keep going. Or sometimes I want to go for a walk, so I'll kind of wait to see how the weather's going. Maybe a bit controversial, but if the Pomodoro is interrupted, that's fine, I think. I usually pause it and come back to it. Maybe more efficient if I didn't interrupt it and I penalized myself by avoiding it. But it felt wasteful to stop a Pomodoro and kind of sickening, or you kind of don't really want to use that technique as much. But if you pause it, it makes it a lot easier to do. Especially if you're living at home, maybe it's not, I don't think you can tell someone, oh, come back in 20 minutes. I think you might have the head bitten off you. My final bits of advice here are to stay honest. So not to stop early, do the full 25 minutes. If you haven't done a full Pomodoro, don't write it up. Don't cheat. If you haven't done the minimum, then you haven't done it, so be it. You'll work harder the next time. I think you should keep simple. Some people like to use a fancy app or start to use Excel to track everything. I think just a handy little timer widget on your desktop and a Google Keep Note or a scrap of paper is all you need. At the end of the day, it's just to do concentrated blocks of work. And lastly, to try not break the chain. So there's an idea that if you can get into some sort of a streak, you're more likely to continue the streak. So if you always decide, I'm going to do 9 Pomodoros a day, that's a nice streak to try keep up. Especially towards the end, I was able to keep a good streak, and that keeps you motivated. You always want to maintain that Pomodoro streak. So that could be something you could use to motivate yourself. So that's the end of this presentation, and I've just attached some further reading in case any of those articles might interest you.
Awesome. That's a really great talk. You know, I'd never looked very fully into the Pomodoro techniques. That one of those things is kind of on the periphery that you kind of hear about a lot, but this was really interesting. And I quite liked your last bullet point to protect the Pomodoro, because it definitely gave me images of, like, you know, ninjas coming in and trying to steal your timer.
Yeah.
But I was wondering, did you have any tips for estimating how long a task will take? Because I know.
No, I'm so
Okay.
terrible at doing it. No. After time, you get a small bit of
Yeah.
a sense, but no, it doesn't get too much better.
Okay.
After the first week, you get a bit more realistic. All right, that assignment actually will not take 3 Pomodoros. It'll probably take 10 by the time you proofread. But if you start to break it up into stages, as in write it, draft 1, draft 2, then you can kind of get a little bit better by doing that. So break it up, be super granular. It's easy to estimate smaller chunks.
Yeah, no, that makes a lot of sense. And I think it is an unfair question for me to ask, because
no, not at all.
It's not a solved problem in software engineering at all. But yeah, so this is obviously very helpful for those who maybe don't have the willpower to do long periods of concentrating. Did you find that it helped with, like,
definitely,
that kind of problem?
Yeah. I wish I did this during my internship, because I also had problems there as well. Like, you get bursts, but then you'd end up on your phone. Then all of a sudden, oh no, half an hour is gone.
Yeah.
But this helps you keep a better structure, a more measurable structure, and you stop feeling guilty about it. I know I did 9 Pomodoros of work. I can say I can stand behind that, and that gave me a lot more peace of mind when I was doing work.
Yeah, I really liked your tip of staying honest, because it is very true that in a lot
it's so easy to cheat. It all falls apart then. You stop doing it properly then.
Yeah, and you get like a very definitive sense of satisfaction from actually doing it, because you know you achieved it and you know that it's working to a certain extent.
Yes.
So yeah. Well, thank you so much. That was a wonderful talk.
Well, thank you.
No problem. Up next, we'll be having Oisín Quinn, who's going to be talking about how JavaScript is good, actually. So JavaScript has some good parts, and Oisín is going to tell us all about them. I'm super looking forward to it, and I'll see you all in about maybe 5 minutes.
Hello. My name is Oisín Quinn. Nice to meet you. How's it going? And I am here to talk about JavaScript and why it is actually a good thing, and a good programming language and all that crack. So I'm going to fire away here. First of all, hi, how's it going? Nice to meet you. My name is Oisín. I studied computer science in UCD. I was pretty involved with UCD NetSoc for 2 years. Then I graduated last year, and now I am doing lots of fun front-end stuff at a company called HubSpot. So first of all, I'm not an expert. Second of all, 10 minutes is a really short amount of time, and I'm going to be going into like not too much depth about things. Hopefully I won't be rushing too much, but yeah. First of all, everybody seems to hate JavaScript, and that is the one thing I've learned from my time studying computer science. JavaScript is just hated by everyone. I'm involved in the UCD NetSoc server, and the amount of times people have just said bad things about JavaScript, which are deserved, to be fair. Bad quirks to JavaScript and like funky stuff it can do. Lots of examples of that. But even outside of NetSoc, in like the wider TypeScript community or JavaScript community, or the computer science community, there's lots, like JavaScript is always like the butt of the joke, I guess. And I'd like that not to be the case. I think JavaScript like gets a lot of, negative attention, which I don't think is completely deserved. So all the people who say those things are wrong, and it's really important that you remind them that every time, because JavaScript is not bad, it is good. My favorite things about JavaScript, I think one of my favorite things is just the syntax is really nice, and I just love writing and like reading and like just everything to do with JavaScript. I'm a big fan. If I talk a bit about objects, so objects are kind of key in JavaScript, and I just think they look great. So here I've got a person object, and I'm just defining, okay, here's the age, here's the name, and then I can say the address is another object, and I can just like nest these objects inside each other, like without any hassle or anything like that whatsoever. And if this syntax looks familiar, yeah, it looks like JSON because it nearly is JSON. Like JSON is based off JavaScript. That's what the JS stands for. And if I want to access the postcode inside this person, I can just go person.address.postcode, and it just looks really nice. It works really easily. You might ask, okay, what happens if address doesn't exist? Okay, that will cause some errors, but I will talk a bit about how you can kind of avoid things like that later on. And then another thing is object destructuring. So I have this person variable here, which is an object, and I want to reach into it. So I can use this destructuring syntax here to reach into it and grab the age and like store that as a variable. I can grab the name and then rename that variable to my name and save that. Or I can go into the address and like go into the address then and then grab the country. So this is just a really nice way I find of like getting an object or getting response from an endpoint of some sort, and just taking out exactly what you need, and then you can just use it like that. Big fan of objects. I won't say much about this, but there's string literals in JavaScript. It used to be really messy how you wanted to like put a variable inside an existing string. You used to have to do stuff like this. Now you can just use the backtick and put your variable in there, or you could add like extra white space, and it's all respected whenever you run the code. Arrow functions. So JavaScript is like a oldish language. It's from like the 90s. I guess isn't that old, but I'm also from the 90s, I guess. So you can define functions like this, which is like the old way, or you can use this new arrow function syntax, where I can just say, okay, I have a square variable, and it is equal to this function that takes in, a parameter, and it returns just whatever the code is. It like runs the code between those curly brackets. But I can simplify this even more into just this single line where I'm saying square is equal to, it takes in a width and returns the width by the width. I think this looks great. Like I'm a big fan of this, how like concise it is and how easy it is to read what's going on. And then you can just call it like any other function. But then you can see here, since this is a variable, I can, copy it to another variable, or I can pass it in as a function or as a parameter to another function, or I can add it as an attribute on an object. And I think it's really cool how you can just, pass functions around without any hassle or any bad stuff like that. So big fan of how functions work in JavaScript. There's other cool stuff you can do. So you can have like default values for parameters. So this here generates a greeting where it's just returning a string that says, hey, username, welcome. And say if I pass in Oisín, it'll say, hey, Oisín, welcome. But say I don't pass in anything, say that we don't know what the user's name is yet, or someone forgets to like pass in a certain parameter, it'll say, hey, anon, welcome, which I think is really handy of just, it's just a really nice way of having these fallbacks in scenarios where fallbacks make sense. But you could also, if you want to, you could pass in an object as the parameter instead. So what's actually happening here is it's taking an object that has a username and days since last visit, and it will destructure that using the syntax from earlier to turn these into variables pretty much, and then I can just access them just like this. And this is really useful for when you have functions that are taken in like 5 or 6 parameters or something like that. Or you want it to be really clear when reading the code what is exactly happening. So if you see this here, it's really clear that the 2 means it's been 2 days since the last visit. And if you're using just normal like syntax like this, it's not entirely clear what these parameters are being used for unless you dive into the actual function that's being called. So like you won't want to use this all the time, but in certain scenarios, it's really cool and handy. There's lots of cool things you can do with arrays in JavaScript. So say you have any array, you have all these like helper functions associated with the arrays. So I found this on Twitter recently. It's kind of pseudocode, but I can say for every element inside this array, I want to map it to something else. I want to change it in some way, or I want to filter. I only want to take out certain objects from this array that like pass whatever like function you put into it. I think these are just really handy and like really nice to use. You can do pretty much anything with JavaScript if you want to. You can like make you can just use this one language to make like a front end, make a website that's like interactive, or like a full scale web app that does like solve real problems. Or you can make a back end with like Express and Node.js. You can make mobile apps with React Native. I don't really know about games and AI. I haven't seen much of that, but I think it's really cool how you can like use this one language to do so much stuff. Doesn't mean you should, I guess, is the catch. Like if you're making like an enterprise level like iOS app that needs to like have all these native features, like maybe React Native doesn't make the most sense. Maybe you're best off writing an app in like Swift instead. But I just love how you have that opportunity. Also, there's always new features being developed. There's a committee called TC39 that's made up of like industry people and open source contributors. And pretty much anyone can go to this repo and they can write a proposal of a feature that they think would be really cool to have in JavaScript. And you just like make up a README and you put in like the rationale and like what it would actually look like. I think that's really cool how anyone can go and like add to JavaScript and like, and it's all decided on a community level to see like, is this something we actually want? I think that's great. Okay, sometimes JavaScript can get a bit chaotic, to be fair. It's not perfect. It's definitely not perfect. I'm stressing it is not perfect. Especially things with like, since there's no real types, you're messing around, or like there are types, but they're not really clear when you're like writing or reading code. You could have something you pass in a string instead of when you actually want to pass in a number. And like that gets a bit messy. There's lots of funky stuff going on here, which I don't really want to get into if I can help it. But what I find like the hardest thing with JavaScript sometimes is when you have a big function or like a big like piece of code and you're not really sure what's going on. Say I want to do something with this cached object, but like I don't really know what that is. Like it's not clear what, even if that's an object or what, and like I can go through the code and like I'm not really seeing much. So there's one like really great way of like fixing some of these annoying JavaScript things, and that is to add types with this lovely TypeScript Blue. So TypeScript is a language that is built on top of JavaScript, which is really important. So every bit of JavaScript you write is also valid TypeScript, but it adds types, which like is one of the biggest problems with JavaScript sometimes. So if we just zoom in on like that code snippet there, you can see this goes fixes the problem from earlier where you have a user object and like you don't know what exactly you can access on it. In TypeScript, if you try to get something that doesn't exist, it will complain. So I think that's great. So my conclusion is that JavaScript is a good language and it's got really nice syntax and all these great things, but you can make it even better if you make it TypeScript. And learning TypeScript, if you know JavaScript, you pretty much know most of TypeScript already. Just to finish up, some resources. If you're new to JavaScript and you want to understand the mental model a bit better, this website, justjavascript.com, it's actually an email newsletter that like just goes into like a great mental model for understanding JavaScript. And there's also this talk called What, which is just a comedy talk, pretty much just talking about the bad things or the crazy things you can do with JavaScript. Okay, that's me. Thanks for listening. The code samples are here. I also have them in TypeScript. If you want to see these slides, you can go to that website. And then I am Oisín_Q_ on Twitter. It's the only social media I really use. Cool. Thank you. Thanks for listening.
Awesome. I learned a lot about JavaScript that I didn't know before. One of the things which was in your first when you were showing where you were on blast for it, where you revealed that sorting an array of numbers sorts them alphabetically.
Yeah, that is one I noticed recently when I was actually working, is because it expects you to pass in strings, so it's not great. But it's those kind of things, if like you're dealing with, if you use TypeScript, it'll like tell you these things, it'll show you like the JS doc to see, show you exactly what these things do. But that's like a particularly bad thing in JavaScript that is probably like a relic from like 20 years ago.
Yeah. It was really cool going through the examples. In fact, like I really liked the one, I think it was destructuring you called it, where you could well, I know it as unpacking, but normally in other languages you can only unpack sort of like tuples or arrays. It was really cool to see that you could unpack a whole object into something a bit more. What out of what you presented do you find most useful to yourself on kind of like a day-to-day basis?
I think like I use object destructuring like every single day, like especially when I'm like dealing with React and I've got like props, like it's just so much like easier, and I think it looks really good. I just love how it like it's really intuitive exactly what's happening, and like you can go into like objects inside of objects and like take out what you need. But you do need to be like careful, like it's JavaScript, you've got things like null and undefined that like you need to be careful with because you don't have types. But then TypeScript like kind of gets rid of that problem because you know exactly what you're dealing with.
Yeah, well that actually leads me on to like, at what point did you realize that TypeScript was the thing you have to move to? And when did you make that move?
So it's really, I think around Christmas, I was doing the Advent of Code challenge, and like I had heard all these good things about TypeScript. I was like, might as well give this a go. And like, it just gets rid of like the biggest pain point in JavaScript for me is just dealing with objects that you don't understand, especially when you've got like, you're working in industry, like you've got code that was written years ago that you don't understand. And like, it just means, you know exactly what you're dealing with at every stage. And I really love that. So I think it was,
Yeah, no, that's great. In terms of like, why do you think, or sorry, I'm gonna start again. Why do you think people have this sort of like disdain for JavaScript? Do you think there's any reason, or?
So like JavaScript, like historically has not been great. Like if you think back to things like jQuery or like JavaScript from like, the 2000s or even like the early 2010s, like it really wasn't great. A lot of what I showed, most of what I showed in this presentation, like didn't exist. Like since like 2014, 2015, there's been like so many like big changes. It's probably down to like modern browsers coming onto the scene and like Chrome and all that crack. But like there's been real effort to like modernize. And I think things like in JavaScript move like really fast historically, and like I think it's kind of stabilized a bit recently. But I think those new features like get rid of like most of the annoying things, and then like languages like TypeScript on top of that just like make it even like nicer and safer to use. Entirely. It's been really very interesting seeing how JavaScript has evolved even in the last 5-6 years. It has come leaps and bounds since the early 2000s.
Well, thank you so much. That was a great talk. It was wonderful to have you. Up next, we will be having we'll be having a short break for about 20 minutes. And then after that, we will have Galacia Pokos, who will be talking about building a community for the LGBTQIA2S plus people in a tech space, and what went well, what went badly, and what maybe they would do differently in the future. So yeah, stick around for that, and I'll see you all in about maybe 20 minutes. Talk to you soon.
I guess I still hear the music. There we go. Awesome. Hi, I'm Galacia Pokos, and I am giving a presentation today called From the Ground Up, as it were, a case study in me, Galacia Pokos, trying to build a LGBTQIA two-spirit plus community here in the Midwest. I'd like to start probably with some introductions beyond just my name. I am a level 30 non-binary software engineer, and as I said, I am from the Midwest in the United States, and this presents me with some cool opportunities and some unique and maybe not so unique challenges. In case you were curious, that is one of my cats, Archon, in the photo there, and my spouse, Tyler, in the other photo. So this building of a community was a need that I recognized, and some of you might be asking, why would you take on something so large or so intimidating or so out there? Well, one, I'm an engineer, and engineers tend to be problem solvers. I also like to be helpful and supportive and part of the community, not just the LGBT side of things, but just locally. And in my state's largest city, where I reside, we have about 175K people. And despite that size, I don't know anybody else at my workplace who uses they, them pronouns. And I started using them a couple months back, and my workplace has been really respectful and accommodating. On top of that, in the sort of tech scene of the area, I probably only know 2 other queer folk, and that just seems like a really low number to me. I was like, there's got to be more of us out there. In general, the city and state to which I belong has a lot of room for growth. There was a lot of legislation that was trying to make its way through that was really harmful for young trans folk in the area. And in February, there was some statewide marches in protest for things like that. And so I recognized, yeah, this community in this space really needs a safe place to be themselves and to connect and network. And this is true even of something like the tech industry. So knowing there was a need, my first question was, okay, well, where do I start? And like many of you folk, during the pandemic, I was on Discord a lot in a lot of Discord servers. And so I was like, hey, that seems like a pretty good spot to kind of try and build up this community. Why not start there? And I spoke to a few friends and colleagues to try to confirm the value of that and see if it felt plausible. And I started brainstorming ways of, okay, well, after I start this, how do we make it grow? And that was the easy part, as it turns out. The first couple days, I just sent out invites to my few friends that I knew of, and they were really, really quick to accept those invites and be supportive. One of my friends even offered to moderate the server once it got to a decent size, and I was like, yes, not in this alone. Other people want this. That feels good. I started reaching out to other local groups, tech meetup groups, city inclusivity groups. I even went to the secondary school that I graduated from and asked the inclusivity group there if there was anything that I could pass on for people to kind of filter in into this space that we were trying to create, and there would be a place for them to network and build relationships, despite maybe some of the hardships faced by queer people in the Midwest. And as I started this effort, it began to blend into my workplace as well. I joined this recently formed Diversity, Equity, and Inclusion Committee, which was, 1, giving me more of a chance to practice these skills, and 2, hopefully allowed me to kind of come back with something to help inform how to grow and make my space better for those who would hopefully be joining. That's when feelings really started happening. I recognize that this is big. This is something I'm really passionate about, and I really, really, really want a safe space for people to come in and find resources and opportunities and mentorships, because I was struggling finding these. And on the flip side, there were all of the what ifs. What if the Midwest isn't ready for a group like this? I thought to myself, what if I was going to be getting hate for trying to just be myself and help others do the same thing? What if local folks don't feel comfortable outing themselves online? I thought to myself, there's a lot of people who are part of this community that just don't raise their heads up ever because of the discrimination that we face. And what if the local groups that I'm reaching out to resent me for encroaching upon their spaces, what have you? On the positive side, even that was a little intimidating. I wondered if the community were to ever grow to a certain size, if I would even be able to answer all the questions or issues that would arise inside of our community. And all this stuff was kind of bearing down on me, making me a little nervous. But meanwhile, back at the lab, there was a lot of stuff going on in the Discord that was really positive. There was a bunch of ideas of how to open up more doors for us. We talked about printing out a QR code to put on t-shirts so that people could scan us and join our inclusive space. There was a lot of gender and frog memes for a while, thanks to yours truly. And as June came up, there was a lot of happy Pride wishes, and that kind of grounded me and brought me back to all the positives and things that I thought that this group could be. And after a couple deep breaths, I thought through the more realistic scenarios and what was there really to worry about. Worst case scenario, my 2 queer friends were going to be the only audience for my frog memes. Best case scenario, it goes swimmingly, and I helped to provide a safe, inclusive tech space. These are 2 opposite ends of a spectrum, and there's plenty of other results that could happen in between. And either way, I recognize that there's probably going to be some barriers and bumps and mishaps, but what are mistakes if not lessons to learn from? I am very excited, regardless of the bumps and bruises that we've gotten, to see where this group will go beyond just frog memes. Hopefully, it'll be a thriving Discord group that helps people feel safe and supported and feel like they, belong in the realm of tech, because there needs to be an increase of diversity there for sure. I'm hoping that it'll be a place where people can come to connect with others who are in similar waters. It'll be a place where they can find resources, opportunities, mentorships, and regardless of what people find there, I know for me, it's going to be an ongoing adventure where I'm going to continue learning about myself and hopefully growing as well, as I kind of hope this Discord group will too. And the reason I gave this presentation today was a way to kind of help other people feel comfortable maybe doing something that seems a bit intimidating. Usually if something makes you nervous and excited at the same time, it's something that you're probably doing right by pursuing. So use my failures as proof that you don't have to do things perfectly to have them have value. You have my permission right now. I'm just telling you to go do the thing, even if it's scary, even if you're not sure of where it'll end up. So that's my parting words for you. I think I'm coming up on my time here. So if it makes sense to, we can jump into some Q&A, and I'll leave you with a delightful frog meme.
That was wonderful, and I'm very happy to have your permission.
Yeah.
It's what I've always
Sometimes,
thought.
we don't like allow ourselves permission, and so sometimes you just have to have somebody else say, yeah, you have permission to fail and to learn from it. Go do the thing. So
yeah, it's very true. Not to get too personal, but something that my dad once said to me before I moved country. He said that we often mistake our excitement for fear, and that really stuck with me, because it's very true to what you just said, which is like we don't always give ourselves permission to feel that excitement. We're always concerned with the worry of what will go wrong, the what ifs. And it was super interesting to hear about the what ifs that were going on in your mind. Was there a moment, I know you talked about like that you did get through it, but was there a moment where it kind of settled in and you calmed down and you were no longer in that fight or flight of like, oh, worst case scenario is just my 2 friends and these frog memes?
Yeah, I think like that was the height of my anxiety, if you will, was definitely around the time where I was maybe expecting certain things that weren't happening, or I was meeting some resistances. And what really got me through was just having it be not just my effort, but the effort of some of my friends too. And even just like telling somebody about it and having them root me on, or even like just having that Discord space there and having it go empty for a while, but then somebody make a comment of happy Pride. It was just like those moments and those fulfillments that kind of calmed the choppy waters, if you will. And so I say do the thing, but bring friends, because friends always make things better, right?
And it's dangerous to go alone, eh?
Yeah, here, take this, right?
So I'm really curious actually to hear, if you could do it over again, would you do anything differently?
I think I would. I think I kind of jumped into it because it was an immediate need for me. If I would have been doing it regardless of my personal needs, I probably would have done just a tiny bit more research and networking before putting out the Discord. It's kind of like doing anything where you're kind of self-advertising, like a Kickstarter per se. You don't just want to be like, and here's the Kickstarter. You kind of want to like build up some hype, some excitement, reach out to maybe some people who have more of a following or are already in touch with a community like that. And unfortunately, I was doing so right as people were preparing for Pride. So a lot of the inclusivity groups were probably like, freaking out for all the planning that they're doing, and me on top of it. Hey, I made this Discord. Would you like to help? And I was gonna say the timing was probably not the greatest for me personally. But despite that, like I said, I think that nothing will be sacrificed for me having started a little bit early. I just think it probably would have calmed my nerves and made a more positive experience for myself, and given me better feedback if I would have been doing it a little more structured, right? But
well, I think that's a very good point. And maybe the timing wasn't great in the middle of Pride Month, but but thank you so much. That was a wonderful presentation. I really loved it. I learned a lot about community building and about your experiences with it. So thank you again.
Well, thank you for having me and for giving me a chance to talk about something I'm really passionate about. So
it was our pleasure, sincerely. Okay.
Awesome. So
up next will be Kemet Dugue, who's going to be talking about the React Profiler, a bit more of a technical talk, and he's going to be talking through the React Dev Tools. It's a visual tool that can help give more performance and rendering context for a React app. Super interesting, and we'll see him in about 5 minutes. I'll talk to you all then. Bye-bye.
Hey everyone. Good afternoon, morning, evening. I think I covered all the different times there. Thanks for joining my talk today. My name is Kemet, and I'll be talking about the React Dev Tools, specifically the React Profiler. We'll be doing a live demo as well with a very stripped down, minimal to-do app. Been using Twitter a lot these days, and you can find me on there, as well as my GitHub over there. Cool, so the agenda for today is I'll start off with a brief introduction about myself and an overview of the talk. Afterwards, I'll talk a bit about the React Profiler, sort of what it is, why React developers should use it, different use cases. After that, I'll do a demo I'll demo the Profiler using a to-do app. And then afterwards, I'll provide some additional resources for those that want to learn more about the Profiler, the React Dev Tools in general. And then afterwards, we'll do Q&A. And so a little bit about myself. My name is Kemet. I'm an engineer at Microsoft. I work on the Teams product, which is our workplace communication tool, mainly focusing on meeting-related features. Previously, I worked at a small startup that was doing marketing tech. And much of my experience with React is from working at both of those places. My interests kind of vary a lot, but lately I've been into, well, three things really. Lo-fi house. If you're not sure what it is, you can look it up. Hint, it's a sort of underground music genre. Been into tennis, so playing a lot of tennis as well as watching the Wimbledon tournament going on right now. And cats. I have an orange tabby of my own. His name is Chucky. He just ate, so he's probably sleeping, which is probably for the best. Just a quick note that opinions stated in this presentation are of my own and in no way reflect my current or previous employer. And just a reminder about Q&A that we'll save that to the very end. Cool, so let's get into it. And these two screenshots represent the two different components of the React Dev Tools. But what are the React Dev Tools? The React Dev Tools are a set of tools to help you work with your React app. It helps you inspect your different components, stuff of that nature. And it's really comprised of two different components, for lack of a better term. There is the component section, which we see on the top right. This is for inspecting your components, basically understanding the different component architecture tree, the props that get passed in, information about the props, so on and so forth. And then you have the profiler section on the bottom, the photo on the bottom right, which is used for sort of inspecting performance for your React app. And the profiler is what we'll focus on today. So with a profiler, you can sort of record, or what they call profile, a given scenario and inspect it to get some more information about it. And lastly, the React Dev Tools is available as both browser extensions for Chrome and Firefox and as a standalone package that you can download via NPM or Yarn. Cool, so let's get into the app that we'll be demoing with today. And we'll just go straight to the live version. So I purposely built a not optimized version of this to-do list to sort of really exaggerate the different use cases or the different parts of the React Profiler. And so just quickly going through the component architecture, we have three components that comprise this to-do app. We have our individual to-do component up top, which is responsible for adding a to-do. We have the to-dos itself, which comprise of the individual to-dos. And then the last component is the individual to-do itself, which has a button with an on-click handler that completes the to-do. And so on the right-hand side, I have my Chrome DevTools open. I've installed the React DevTools, so we have access to the components section, which I talked about earlier, but more importantly, the profiler section. I generated some information because I was running some scenarios earlier today, but we can sort of profile our app if we wanted to sort of inspect what was going on. And so in this case, I want to record a scenario in which I'm adding a to-do. In this case, I want to go ahead and record it. So I'll go ahead and start profiling. And what do I need to do today? Play some tennis. So I'm going to go ahead and add that to-do, and that's my scenario. And so here we've seen some information that's populated, and I'll walk through the different parts of the profiler, the different components that comprise of this profiler. So in this main section over here, we have what's called the flame graph. The flame graph is really just the section that shows the component tree for the current commit, as well as including rendering information about each tree. And just a reminder that in the React world, commits are the changes that actually get applied to the DOM versus a render, which comes before the commit phase, which is React trying to figure out what changes to get applied. So it's React phase, the render phase followed by the commit phase. And so the flame chart sort of shows the different components, and there's two main parts of it. There is the rectangular bars of different sizes as well as those colors. And so in terms of the length of the bar, the longer a bar is relative to the other bars, the more time it took to render. So in this case, our parent component, the not optimized to-do list, that's what it was called, that's what I called it, took longer to render than the individual components, than its individual child components, like the to-do input, as well as the to-do list. So in terms of the colors, the yellower a bar is, the more time it took to render, so that we see that in the case of the not optimized to-do list, took longer than the to-do input to render. And that goes to the idea of the blue color. And so the blue color means that it took less time to render. So the to-do input, a child of the not optimized to-do list parent component, took a little bit longer, took shorter to render. And then in terms of the gray color, that means that it did not render for this specific commit. So we can see that up top, and this is just mainly the overarching app component and the configuration and the router that I hooked into when creating this app via Create React App. And so these didn't render for a specific, commit. Up top, we see the commits overview. And over here, it sort of gives in information about all the commits. And again, the commits are the changes that that lead to the actual DOM updates. And so we're looking at the first commit, and we see 17 commits. And so the way we can think of this as is going back to the scenario. So the scenario was adding that individual to-do to play some tennis. And you can imagine somewhere along here, the 7th out of the 17th commit is where I was actually typing in maybe one particular letter of that that to-do that got added to the to-do list. And so in this section, we can see the different commits for that given scenario. And again, the rules with the length of the bar and the color also apply here. So the higher a bar is, the more height it has, the longer it took to render. And the colors means that blue took less time to render compared to the yellow. And so another section we have here is commit information. So when we investigate or look more into a specific commit, we can get some information. The really important figures are the committed at and the render duration. This will tell us how long it took for a given commit to render. So in this case, for commit number 4 out of 17, it took 1 millisecond, obviously very fast, but you can imagine a very complex app that it might take longer to render that you were not expecting. And here we can sort of like dive deeper and look into sort of the problems that were causing that slow render. And so a little bit else about the configuration, you see these sort of like highlights as I'm typing. This is an additional configuration I added. It's within the profiler section. This is specifically when you go to the general tab, you can highlight the different updates when the components render. And then I added one more, which is recording why each component rendered while profiling. So we have our not optimized to-do list. So in this case, I had change of hooks which were not necessary since I was just writing, just adding the to-do itself. And so there's also another view. It's not used as much, or in my personal case, not used as much. And this is the rank chart, just another view. And again, it just orders the components in terms of what the slowest render to the fastest render. That makes sense. And so basically, this is the information that you'll be looking into when you're using the profiler section of the React DevTools. And so going to different resources, both of these are actually, the first one links to the official React docs, which are wonderful. And so you can find out more about the profiler and more in-depth information there. And then there is this really awesome React DevTools tutorial that I found out in the wild, really helpful. It also includes information about the components section and just working more with the React DevTools. Cool. That's the end of my presentation. I will now take questions. Mm-hmm. That's a great question, and let's go back to it. And you can. Obviously, this simple to-do app, totally not scalable, but also for a lot of devs out there that work on more complex apps. And so different ways you can filter is you can hide your commits for a given, depending on the milliseconds. Obviously, if I do it here, I will lose a lot of the information just because this was a very simple app. And if you saw the rendering information, it was just like a few milliseconds. But here is when you're looking at a component that's maybe taking a few seconds to render, which this is a big deal for a lot of users. You can go ahead and filter it, and this will increase the sort of investigation time, if you think of it, finding that information.
Yeah. I guess I was also wondering how much of this is part of your day-to-day workflow. Do you use the profiler every time you build something, or is it just when something goes wrong, or?
Usually, so in the beginning when I worked at a startup, I didn't really know about the profiler. At Microsoft, a lot more users. I think there's like 140 million users, daily active users for Teams. So I'm looking into this consistently. And before we get our, before we ship different features or, get our code into this sort of master branch, it is recommended that a lot of the devs sort of use these tools. They also have a lot of internal tools that we use, but I also always find myself using the profiler. Okay, awesome. That's really cool to know. Well, thank you so much. That was really awesome. I really love the live demo aspect of it. It's really nice to see things properly. Yeah, thank you so much for having me. I hope everyone enjoyed the talk. Thank you again to Evan for putting on this, and also anyone else who helped out with organizing this, and to the awesome speakers. Thank you so much. Okay, so all right, everyone, have a good one. Up next, we will be having Sia Seko, who is going to be talking to us about growing with compassion. So he's going to chat about how we can be more compassionate when relaying information, as it shapes how the receiver interacts with it and shares the content with other people forever. So it's kind of how, when we relay information, how it will affect people in the future. It's a really cool talk, and we'll see it in about 5 minutes. So I'll talk to you all then.
Hi, everyone. I am Sia. Thank you for hanging in until the end. Thank you, Evan, for setting this up. So I am based in the US as well. And I want to talk to you today about one of my biggest realizations as I'm navigating and growing in my little tech ecosystem of data science. So before I do that, hopefully I can convince you by how my days are spent. So like all of you, I like to learn. I have the privilege of accessing online content, and some of it is free, some of it is paid for by some really good Samaritans, but that gives me a lens into how content creators kind of shape their information and how they think about delivering it. It could be videos or reading. So that's one lens. And then I also spend my Saturdays, not today, but most of my Saturdays as a teaching assistant at a data science bootcamp that is really people from all walks of life that come to try and be more data literate, regardless of the industry they're in.
Apologies for interrupting. We can only see the preview of your slides.
I'm so sorry.
No, you're fine. I should have caught that when we were. Yeah. Okay.
Are you good now?
We're still only seeing the PowerPoint view of it, like the editor.
Oh wow.
I think you might be sharing the wrong screen. It's no worries. I mean, you're also the last talk of the day, so you can go over. There's no problem.
Yeah, this is funny. So, what do you see now?
We still just see the PowerPoint editor, on the third slide.
Oh goodness, this is fun.
I think you might need to reshare your screen if you want to stop it for a moment.
Yeah. Well, happy Saturday, everyone. This is shaping out to be really great. Let's see. I will present my whole screen and see if that helps.
Sure. Okay, yeah, we can see it now perfectly.
Oh, great.
Sorry about that. Thank you so much.
So let's see. I told you about me learning things. And so I also teach on the weekends, and that gives me a lens into how other people learn. And so there's all these different people from different industries, and they learn differently because they have different contexts. And at work, I get to be both. I get to be a learner and a teacher because as a senior analyst, I have people who will ask questions or I write documentation that they read. So I am transferring information to other people. But also I have questions. Sometimes I don't know things and I want to ask questions and I learn from other people. So it's both ways. And because of that, you get to see how we all interact with information differently on a spectrum. It is more of a circle, but a spectrum seems like an easier concept to visualize. So for example, in this scene, if you have seen the show, it's pretty funny, but in Schitt's Creek, we have Moira, the mom who is trying to cook and trying to convince her son that she wrote this recipe. And they're making a sauce. They get to this point in the instructions where it says to fold in the cheese. And David doesn't know what that means. And Moira doesn't either, but she pretends to. And she keeps saying, well, you just fold it in. You just fold in the cheese, David. I don't know how else I can tell you that. And of course, at some point, he gets really frustrated. He leaves the kitchen. There's bubbles in the sauce. There is no dinner. So that's a mess. And we don't really want to be in this example. We don't want to be the student, the person who's intaking information, or the person who is giving it. Because if you think about it, she is a little frazzled. She's having this point of view as a teacher, but she doesn't really know what she is teaching, which is bad. So we don't want to be in that position. because one, we don't want to repeat ourselves. That means we're not listening. We're not taking in the context of the person who's talking. We're just in this mode where I need to transfer this piece of information and I'm doing it. And that's not really the point. We also don't want to say things like, this will be easy, and oh, this shouldn't take long. Now, this might be what you say to make someone feel better, you think, but say you're teaching me something or you're explaining a concept, and then by the end of the explanation, I am confused. Maybe you're showing me how to print hello world, and I still don't know how to install some package. So I'm lost. I thought it was easy, and now I feel like, oh, this was supposed to be easy, but I don't get it. So no success. And the reason that we tend to default to this is because as humans, we stay on the side of empathy. So one of my favorite thinkers online is Tatiana Mack, and she wrote this at the height of the protests last year, where compassion does not need you to understand what other people are feeling or experiencing. It just needs you to believe it in order to help them or to support them. Whereas with empathy, you're trying to draw from within by definition. And this same thing applies to teaching. You don't want to always have to know how this other person learns. You're trying to help them without really putting yourself in it, because that's more successful for them. This is like, it's a chain of information. You are showing someone else and they will show someone else, and how you do that affects how they know it and how they do it for the next person. So it's like this responsibility chain. So very simple, you can listen. If someone is asking you for help, make sure you have all the information before you just tell them. It might be that they don't know what an IDE is, and you're trying to tell them the command for printing is just print. You're not on the same page. Also, if you have gotten to the point where you have explained something and you've already done it, you should still talk again, check for understanding, kind of meet them where they are. If you think of it as a bridge, you want to walk to the point where they're stuck and walk back with them to your side. You don't want to say, hey, I'm watching you, walk towards me, it's fine, because they don't know how that feels. So in that vein, we should also be comfortable saying when we don't know things, because it would make the other person feel comfortable. You know, if you're nice when you're doing something, it really translates. People really can ease up when they're interacting with you if they know that you're being honest with them. If Moira would have just said, I don't know what folding the cheese means, let's Google it, they would have had dinner that day. I mean, we wouldn't have had the funny scene, but, you know, they would have had a good sauce. So it's okay to say, I don't know. It's very freeing. And the only way we can get to that point is if we as people are surprised, nicer to ourselves, because we do tend, we're very human, we will default to empathy. So even if we do, we want to try and make sure that that default is projecting something compassionate and kind to the next person, so that they also feel like, hey, I can do this. And like RuPaul says, if you can't be nice to yourself, how are you going to be, I'm messing this up, but you know, like do it for yourself so that you can do it for someone else. And that is the same lesson with this. So thank you for your time. Apologies for the technical difficulties, and happy Saturday.
Thank you so much. That was really great. I really loved your use of GIFs, and I loved the message. It was super good.
Thank you.
I would also like to start off by saying sorry for the technical difficulties. I think that was my fault. I should have caught that in the pre-check.
That's okay.
But yeah, no, I really loved that idea you had from Tatiana Mack about compassion over empathy. That's a really important distinction. I guess, like, what makes that distinction for you? What is the difference between being compassionate over empathetic? I know you outlined some things, but I'd love to hear you expand on it a bit more, if that's okay.
Sure. So Evan, thank you, first of all. You've been here all day, and your team. But so the distinction for me, I can give you an example, is I grew up, for 2 decades, I spent in East Africa. The whole context of my life and how I learn things and how I take second chances is based on that culture, right? And then I come to the US for this last decade, and people are more open to failing. People say you can fail a class and retake it in college. And then if you think about a student who is in that mentality, they're not lazy. They maybe have other things going on in life. So if a student comes to me, for example, on Saturday and says, hey, I really need an extension, I can't go, well, why do you need an extension? I really, at this point in my life, don't necessarily, if they're a good student, I'm not going to look for a reason, because I'm trying to find something that I would approve of to give them an extension. But they just need an extension. You don't know.
Yeah.
They could have been having a bad day. It shifts the focus from you and your experience to making space for what they need. That's for me the distinction.
Yeah. No, that's a really good point. You put it very eloquently. And you said something that really stuck with me. It's something I've heard before, but it's that kindness is about meeting people where they are, to help them. That's something that I really liked and I really loved, and I think it is very true, especially related to what you just said there. Being kind to yourself can be kind of hard, though. Do you have any tips, or do you have any ways that you personally love to be kind to yourself with?
So I like to learn, I said, and sometimes I'm trying to solve something and it's just not happening that day. It's not. And sometimes you have to say, yesterday I knew more than today. Let's celebrate that small win. Celebrating small wins essentially allows me to see that I'm making progress. So I can take a break today because I am not having a bad month or life. I'm just having a bad session while learning. So just acknowledging your small wins, I think, is a really great way to do that.
Yeah, no, it's very true. Often we beat ourselves up for how we view ourselves, not necessarily how things actually went.
Yeah.
And I think weirdly it calls back to the Pomodoro talk, which is about being honest with yourself and being honest with what you're achieving and how you're treating yourself. I think that's a very good message. Thank you so much. This was a really great talk. And I just saw that someone in the chat said that they really appreciate the distinction between empathy and compassion. And they said thank you for sharing. So I just wanted to relay that.
Thank you.
So with that, I would like to say thank you one last time. I know I've said it a bajillion times at this point. And thank you for doing your talk today. I'll talk to you soon. And I must wave goodbye now.
Bye, Evan. Thank you so much.
No problem. Bye-bye. So that leaves just me and this screen. Today has been really wonderful. We had 14 different speakers, all talking about different topics, very different topics, I would say, with some common threads throughout all of them. And I really appreciated it. And the first thing I really want to say is that it wasn't just me. I know I'm the face of what you see here. I'm the face of what you probably see in the Discord, possibly even on Twitter with me hounding people to come watch it. So I want to say a massive thank you to my co-organizers, Nicole McCabe, who was responsible for the Discord and the community and so much more that you didn't see. And I would also like to thank Richard Walsh, who was also key in getting this started and organizing helpful speakers for the speakers to help them through help sessions, and also so much more than I can relay. So thank you to the both of them. I'd also like to say thank you to all of our speakers today. I legitimately didn't have a single bad speaker. There were some technical issues, which mostly my fault. Put up my hands. but I really enjoyed learning so much today, and this is one of the reasons why I wanted to do this. Was I like that, like Sia just said, I like learning, and I also wanted to see from so many different perspectives from all over the world, from different backgrounds, and different personalities and different traits, and I think we really did accomplish that today. So for the last time, I'd like to thank you for watching. I'd like to thank the organizers, my co-organizers. I'd like to thank the speakers, and I'd like to just say that this was a really good experience, and hopefully we can do it again in the future. Thank you, and goodbye.